Thank you. Good morning. Good morning. Let me share my screens along to make sure everything is okay. Just need to... Okay, you should see my screen now. Let me know if you see it or not. Let me stop and share again and see if that helps. Any luck now? Just make sure you click the correct one. Still nothing. Is it showing now? Thank you. Maybe let me write something like, hello, how are you? And you tell me how it goes. Because we've got some other students back, so it's quite full here. So we'll have to see how the network keeps up today. So let me write, hello, how are you? Is it going like very laggy or is it good? It is working. Thank you so much for checking and letting me know. All right, let's hope all goes well. Yeah, it might be a little bit laggy, but you guys can hear me. Yeah, if you can hear me, then you'll hear me say what I write most likely. Or is it? Let me maybe go to the next slide, see how that goes. So I'm just gonna say a few things and you let me know. Our first example is fixed charge, and we'll be looking at literally a fixed charge. And we're gonna set up an IP, which will have few elements that will be new, but a lot of it will be the same as you are used to. But that will be new, will be binary. How is that? Is it okay-ish? Good enough? Awesome. Thank you so much. Okay, so before I start though, I just want to say something. You probably saw class S1 has a smaller weight. So if Friday didn't go well, because I know some of you are working and some of you had doubles and it was quite probably a rough week last week, you still have a lot of chances or assessments to make up for it. But you need to put in the effort. So if you saw that you struggled quite a lot last week, then you need to practice a bit more, all right? Yeah, the next stuff are very logical, but the algorithms are very easy. But yeah, if you saw you struggled, put in a little bit more work. Yes, I'm expecting it's a bit to do with time, but it will always be. So try to practice enough so that you, how can I say, don't get stuck on literally anything. Okay, so the easier stuff is what you spend less time on, and then you can have some time left for the more difficult stuff. Yes, I not move to Monday, just move to the Thursday, but yes, it's on the announcement. We didn't move it to the Monday due to the fact that the next week you're already writing on the Thursday. So we couldn't move it to the Monday. We had to also move it to the previous Thursday, the day before. Okay. Just because of that holiday, that public holiday for the summative. So we had to make that a Thursday, and then this one. Okay, good. And then this one also a Thursday. Okay. But please spread the news if you know someone also attending this course. Please spread the news. I don't want anyone to miss out. I'll probably send that announcement through a message as well. But then I'm sitting with 100 and something messages, so I'll see. I'll think about it. Right. Yeah, I don't work with the career day stuff, so I can't confirm whether there's another one or when or what. I just know there's one on the 2nd of August. That's all I know. Right, there could be more, but I just don't only know about that one. Okay. All right, let's continue. So the first topic of this week is called fixed charge. So we set up an IP, which you can then solve with any algorithm, except Hungarian, because it doesn't fit it's not really a matrix. It's just saying this item requires this and this one requires this, but it's not really a matrix. Just a table to help us set up an IP in a sense. Right. Then we're going to go through location IP, which is basically something you can use Hungarian for. And then I'm going to show you what to look at for logical constraints. Tomorrow we go on with IPs. And then we're going to start with the knapsack IP algorithm, which is going to help you quite a lot for your assignment. Let me see what's next. Then it's set covering, then combinatorial. So a few things this week, but luckily we're getting to the knapsack as well. So that's the knapsack and combinatorial. Those are algorithms that are quite not too difficult. I'm not saying it's easy, but it's not too difficult. So at least you have some way of, I'm going to say, having some calculations help if you struggle a bit with the IPs. All right, but let's see. So the first one is fixed charge. Now, what you need to know about fixed charge is there will be some kind of amount that will literally be fixed. So if you're setting this IP for, let's say, production for a year, there will be some kind of amount that will be fixed for that year. In this case, we're setting it up for a week, so per week, and there's literally fixed charges for that week. So something like rent. You'll pay the same amount per month, for example. It's only when it changes, then you now reset up this IP or set up this IP again. But it doesn't change very frequently. So for a while, it's going to stay that fixed amount that you're just going to either pay or not. I'm hoping you're going to pay it, but you're either going to pay it or not. Okay, so that's the idea, but let's get into it and see how does it work. Right. So first things first, let's set up the basic IP, the parts that are easy for you guys to identify, and then we're going to add on to that. So I just want to open my writing tool. Let me just get my journal there open. Okay, so I just want to have that there. No. So in the beginning, we have to identify our decision variables, and then based off of that we're going to set up our IP. Now, you'll see there are some pieces that I'm not going to write immediately, so bear with me. We'll get to those. All right. So we're first going to work with what we do have and set up the basic IP, and then we add on to it with the stuff that you guys are not familiar with 100% yes. Okay, so let's see. They give us, in the first table, they tell us that Amandla is capable of manufacturing 3 types of clothing, so tell us shorts, pants. Then the manufacturer of each type of clothing require different type of machinery. Now this part of the machinery I'm going to come back to, because what we need to take note is these are fixed costs. Who can tell me why am I saying it's a fixed cost? Why am I saying something like the shirt machinery that is 200 per week is a fixed cost? You can guess or give me some information. What are you thinking? What you're thinking? Rent to use it, exactly. It's rent to use it, to use a machine. And you're going to pay that 200 Rand or not. So if you pay it, then it's going to be seen as a cost that you're going to have to pay. If you don't pay it, then, well, then you're not subtracting that cost. But it's going to be a fixed cost to say, okay, that amount is not going to change unless there's some kind of increase. Yes, so it will always cost the same amount to use that machine. So whether I make 100 shirts, will it make a difference? If I make 100 shirts versus no shirts, will it make any difference? Think before you say. Will it make a difference if I say 100 versus no? It won't make any difference to the cost. Right, won't make any difference to the cost. All right, so if you're gonna make 1 shirt, it's gonna cost you to use that machine 200 Rand. If you're gonna make 100 shirts, it's gonna cost you 200 Rand. We'll later on set up constraints so that if they have kind of limitations to say, oh, the shirt can only produce like 100, then you have to hire another machine. Then we'll add on to that. But for now, you're going to pay that 200 Rand no matter what. However, now the tricky part is to know that it does have a slight difference when it comes to no shirts at all. So if I make 100 versus 1, you're going to pay 200 for shirts because you're going to hire the machine to produce shirts and then you have to pay that amount. But will I be hiring the machine if I make 0 shirts? What do you guys think? Will I hire it then? No. So if I don't hire it, I have to then make sure that we don't pay because we're not going to hire the machine. So just to put that out there, we're going to come back to this and figuring out how will we put this into our IP. You probably have already ideas, but we'll come back to this. Okay, now going back to the stuff that you are used to, they also give us resource requirements. So they tell us for the specific clothing types, we have certain amount of hours in terms of labor that it will require for each, certain amount of cloth meters square that it will require for each. So hint, hint, there's going to probably be some kind of constraints. Let's see. To manufacture each type of clothing, you'll see they require certain amount of labor and cloth is shown as the first table, shown in the first table. Then it tells us in the week how many hours are available. You see we're working weekly. So this IP is for specifically weekly production. So then we go and say, okay, there's 150 hours of labor available and 160 meters square of cloth available. So if I take the 150 hours available of labor, what will be my sign and my right-hand side value for that constraint? What will be the sign and the right-hand side value? Good, very good. So we're working specifically with, let me just use a thicker pen, but that's not thick enough. Maybe, yeah, that's okay. Yes, very good. So less than or equals to 150 because we cannot use more than what is available. So less than or equals to N150. What would we do for the cloth? What's the values for cloth? Meters square. Very good. It's all in terms of meters squared, so we can leave it as less than or equals to 160. It's still meters squared. Now we go back to our table and we say, okay, we have to actually have the coefficients ready specifically for that constraint or those constraints. Let's start with labor. What would be the values for x1, x2, x3, our usual, the usual LP? Very good. So you look at the labor hours, and for each item, you're going to go and put that as a coefficient. So in actual fact, our decision variables are going to be the amount of shirts, the amount of shorts, the amount of pants. Right. So you want to produce a certain amount of shirts and a certain amount of shorts and a certain amount of pants. So we're not going to make this whether you make pants or not. Otherwise, why are you going to look into renting machines? Like, you have to make a certain amount before you think of machines. So we're going to keep it as our x variable, where it's going to be the number of the items, where I is equals to number 1 would be then your shirts, 2 would be then your shorts, and 3 would be then your pants. If we get to the sign restrictions, what are we going to say for x variables? Are we going to say binary? Are we going to say integers? Are we going to say greater than or equals to 0? Or are we going to say more than one thing? What are we going to do there? Int, very good. If you're saying the number of, then first of all, we're going to have to specify greater than or equals 0. Very good, Henry. And then we'll specify int, very good for the rest of you, because we don't want half a shirt or a quarter of shorts. I mean, if the shorts are made to be quarter pants, it's still a full short, right? Okay. Then give me quickly the coefficients of the cloth constraint. Let's see if you guys are okay with that. Very good. So we've got our 4x1, so 4 meters squared for a shirt, 3x2, 3 meters squared for a short, and 4x3. So just to recap, if we were to say they make 20 shirts and 0 shorts, I'm just saying if it's not the answer, and let's say 10 pants. If I substitute this into hours of labor, you will have 3 hours it takes for a shirt. Now, if I got 20 shirts, it's going to be 3 times 20. All right. Is it too bad or is it okay? I can't really do anything about it, though. Is it okay enough to continue? Otherwise, we might have to ask someone else to take over. It should be fine. Everything's still on the slides. It's just explain here what I say. And it should be okay enough. As long as you can hear me and understand what I'm saying, then we should be okay. Thank you. So basically, I'm just recapping the fact that if, let's say you had 20 shirts and you say 3 times that 20, or 3x1, it's 3 times whatever x1 is. So 3 times 20 will then have a value of 60. What is that value? It then means 60 hours of labor, because 3 hours of labor per 20 shirts will then cost you 60 hours of labor. If you then do the 2 times 0, if you are not making any shorts, you put 0 into x2, and then 2 times 0 is going to give you 0 amount of hours of labor, which is perfect. I mean, you're not using any labor, so then it's going to multiply with 0. For the 6x3, so if you substitute, for example, a 10 in there, you're saying that 10 pants should be produced. So 6 times 10 would be 60, which would tell you then it will require 60 hours of labor. Then is 60 plus 60 less than or equals to 150? 60 plus 60 less than or equals to 150, is it? Come back to that true false thing. Yes, so those answers would work for that constraint, for example. If we substitute into the second constraint, 4 times 20 plus 3 times 0 plus 4 times 10. So we're still saying 20 shirts, 0 shorts, and 10 pants. In that case, for those of you who can see my screen, how much meters square cloth would be required for shirts only? How much meters square cloth would be required for shirts? If I use this answer of x1 equals 20, x2 equals 0, and x3 equals 10. Yes, very good. 80 square meters. Oh, just be careful there. I'm still going to add the next one. How much is it for pants now? Perfect. Right, so you've got 80 square meters of cloth that is required specifically just for shirts if you substitute that in, and 40 just specifically for pants, and nothing for shorts because you're multiplying it with 0. Would that answer of 80 plus 40 be less than or equals to 160? 80 plus 40 less than or equals to 160, would it be? Yeah, so that answer would even work for the amount of cloth. Definitely not the best answer, guys. I'm just giving an if here, right? An if, we're playing around with it. But yeah. Okay, so that's just the idea. Just wanted to make it clarify why it's integers and how the coefficients work, just to make it clear. Let me see if I open the thing bigger. Maybe it might work a bit better. I'm just going to close Windows Journal. Maybe that's what's bugging on your side a bit. Just going to close and reopen. Maybe change the view a bit. No. Let's see if I write now that it will be better. I'm testing as we go along. All right, so those values are the easy values to work with. Now let's think about formulating an objective function to maximize the weekly profits. So you guys already know this by now. For profits, what do we do if we look at that table? What minus what? What minus what? I'm going to rather use my other journal app. And close that one. Very good. Your total, we'd rather say revenue, but yeah, the amount of income, the amount that you're getting in, or total income, total revenue, but minus then your costs or expenses. Very good. Right. Just want to call this LPR. Right. Let's see if this will work a little bit better. Okay, so we're going to then say, revenue minus cost, and that will give us our profit. All right, so we check our table in terms of X1, X2, X3. So for each, you're going to go and say, okay, let's say specifically for shirts, it has a revenue or an income of 12 per shirt, so 12X1. Then we're going to subtract the cost for specifically shirts, so that's 6 Rand per shirt. Right, then the next one's going to be plus 8 per short, so times shorts to be able to say times 2. Let's say, for example, 2 shorts, then it will multiply and give you the amount of income for each because you're multiplying. Right, then it's going to be minus the cost of 4x2. Just double checking, you guys can still see my writing. Is it better or worse? Awesome, thank you. Then the 15 for pants minus the 8 for pants, so it's per pants, right? And we want to maximize profits. Okay, so going from there, like terms, so what's going to be the value for X1? Because you're not going to leave it like that. What's the value for X1? What's the value for X2? And what's the value for X3? Good. 6 for X1 plus 4 for X2 and plus a 7 for X3. Perfect. Very good. Okay, so I've got that. Now I'm going to write the other stuff just below so we've got it and we can modify where needed. So I just want to do this quickly. Then we had our labor, which was in terms of hours. So just make sure everything is in terms of hours, which it is, but yes, just want to write all of this over. Then we had our cloth, which was all of this. Just writing everything over that we already written. Thank you, Caitlin, for that. And then that was 160 for cloth. All right. Okay, so that's our IP so far. We're not done, but that's our IP so far. And then you would have specified xi greater than or equal to 0 like we discussed, and xi integer. But we're not done because we still have those machinery costs that we have to include. So in terms of the IP itself, though, there's nothing else. We're done with all of that. But now we have to include these costs per week. Now, my big question, if I pay 200 Rand for that shirt machine, you already identify the fact that you either rent it or not. You're not paying the machine for every single shirt. We already identified that. But will I then, for example, take this, let's say 200 Rand and say it's for X1? Will I say 200 X1 if X1 is the amount of shirts? Would that work? Would that make sense? I'm glad that was a quick no. No. So if we say 20 shirts, how much will you be end up paying for one single machine that costs 200 rand? You still should be paying 200. Very good. But with this, then it's going to be, yes, 4,000, which does not make sense. I mean, it doesn't matter how many shirts you're going to make in that machine. It's just one machine. So if your X1 is going to give you 20 because it's deciding that you need to make 20 shirts, you're going to substitute it back in there, and it's going to be literally 4,000 that you have to pay for that machine, which is not true. You're not paying 4,000 for the machine. It is 200 rand for the machine. Right, so now it comes into the fact that we have to bring in new variables. So now you'll have Y variables, right? So it doesn't have to be a Y. I'm just saying a different variable so that we can identify that X's are for integers and the Y's are for something else. So we're going to introduce now a Y variable, so Y, and we're going to specify how many Y's. How many machines are there that are fixed costs? How many machines are there that will have fixed costs? Christian, are you sure about that? Three, that looks much better. Editing your post there. Three, that's much better. Right, there are three machines, one for shirts, one for shorts, and one for pants, right? If they said they have a machine, then you wouldn't have included it. Like if they had only needed to rent a shirt machine and a shorts machine, then you only need Y1 and Y2. All right, so the amount of Y's will be for the amount of fixed costs that you have to then include. So we've got three machines that we need to include for or take note of their cost for. And so that means we're going to have three different Y variables. Now, if they had the same amount, you would still have a separate Y, because if I take, let's say this 150 was also 200 rand. That value is specifically for shorts. So even if it does have the same amount for shirts, it has to link with the correct variable, because you can't say, oh, okay, now I'm producing shirts, but then you pay for the shorts machine. So even if they have the same value, you'll have different Y's. So you'll have your Y variable that will specify whether or not that machine will be rented or not. Okay, so just to go back here so you can see, going back here. So Y is whether that machine will be rented or not, whereas you have machine 1, which is for shirts, machine 2, which is for shorts, and machine 3, which is for pants. Okay, but how do we put that in? Okay, so going back here, let me just do this and then scroll back to that. What do you guys think in terms of the objective would we do? Let's quickly focus specifically on the shirts machine. What do you think we would do? You now know the variables, Y1, Y2, Y3. You know your objective function is profit. What would we do? What would we put in? So I'm just going to say here 200, I wanted to say shirt. Maybe, sorry for that ugly shirt there. Then 150 for shorts. And the other one was 100 for pants. 100 for pants. Let's see what you guys think. What do you think we will do? Well done. Yes. Remember, all of this is our revenue minus cost. So you have to remember that it's still revenue minus cost. So if you have more costs, you have to subtract those costs. Very well done. So you have to subtract the costs. right? Which cost? So specifically 200 is for the shirts machine, so for Y1. Then 150 is specifically for the shorts machine. And then you also need to subtract the 100 for the pants machine, right? So you're subtracting. Why can I not actually subtract from the x's? Because they're not like terms. They're not the same variable anyway. All right, so you can't just subtract. It's going to stay as is. So all the revenue and then minus each of them. Very well done, Caitlin. So if we go back here, our objective is then going to be max z equals to the 6x1 plus 4x2 plus 7x3 minus the 200y1 minus the 150y2 and minus the 100y3. If I were minimizing costs, would I still subtract the y's? If I was minimizing costs, would I still subtract the y's? If I was only working with costs and trying to minimize it, would I still just subtract the y's, or would I then instead do something else? Well done. You will add, right? If you were minimizing costs, you're going to add all the costs together. Yes. So you would go and say the cost for a shirt plus the cost for the machine for a shirt, for shirts. So then you'll be adding, right? But because we're maximizing, you're saying you take your revenue and you actually subtract your costs. Okay, so just making that note there. All right, so that's nice for objective, not too difficult, but will that work? I'm going to tell you now, no, it will not work. But we'll discuss why not. So right now, just remember to specify that your y's are actually binary. Why is it binary? Because either the machine is rented or not. You're not paying for every shirt. It's one machine for a bunch of shirts. So either the machine is going to be rented or not. Okay, so that's binary. So now you've got a problem that of integers and binary. Right. Now we go on to say, okay, will this work? No, not yet. So just to explain. So if we take our IP as is and we try to solve it right now, you're going to get answers that will not change those y variables. All right, so it's going to try and not subtract any costs, and it's not going to subtract any costs if there's no reason to subtract costs. So there's no link yet between if I make shirts, will I be renting the machine or not? There's literally no link. Right, but just to go back here, if you were to solve this, I'm not going to solve it. You can go and check step by step how to solve this, but for your variables, so you'll see there from U16 to W16, these are our x variables and they should be integer. For x16 up until z16, you'll see those are the y variables and they should be binary, so you're adding constraints to specify that. And then obviously the rest is just your normal constraints, and this is your objective function. You want to maximize what are the decision variables, etc. All right, then you solve as a simplex. Now, sorry, there are other options that you can use, but yeah, we'll stick to these. But hint, there's something here to kind of give you some more information, which I'm not going to show you. All right, but this is if you were using OpenOffice. Solver will work exactly the same. It just has different wording, but it looks pretty much exactly the same. Right. But please remember to do in the sum reference that sum product, which you highlight the top and the second, and you lock the first, etc. Please, please, please go through that again. It will help you just have a quick answer before you start. Right. But going on, what do you guys see is wrong in this solved solution? What's our problem? Can you identify what the problem is with the answers we have right there? Let's see. Yes, well done. There's no machines that's being rented. Very good. Well done. And should it be rented? Yeah, no machines, no work. But what's happening there with the X variables? It should be rented, yes. Like you're saying x1 is equals to 30. So if x1 equals to 30, you're making 30 shirts. So I need to rent a shirt machine. Right, which in our case, y1 equals 0, so something's wrong because there's nothing yet linking the machine to the actual variable. So we need extra additional constraints to make that happen. So I want to make it very clear. If you don't add constraints, nothing's going to change. It will never do anything. All right, so it's going to keep on leaving that as nothing. Same as with X3, you're saying I'm making 10 pants. All right, if you're making pants, you need to rent a pants machine. It doesn't matter for X2 because X2 is 0, so we don't care about X2 right now. I mean, 0 for X2 will give us a Y2 of 0, that's fine. But for the other two, this is problematic because they have no machine being rented, which they should. If you're making that item, you should be renting that machine. So we need some kind of linking constraint. Let me teach you how to use the linking constraint. So here you see we call them the Y constraints, or your linking constraints, something to make sure that those Ys actually, or those fixed costs actually get used or paid if something is made. So linking constraints. So you'll see sometimes in textbooks they will write it maybe like this, so like an xi less than or equals to m and the specific y j. They won't say I because I is, okay, you can still use that because it's still I is shirts, one is shirts, one is shirts for y. So they match, you can still use I. Not that it's such a big deal, but it's just to include, to say I don't have to rewrite 1 equals shirts and then say that's for I and then j, 1 equals shirts. I mean, if it's the same, why not just use I? So just to clear that up. But what is this m value? M is the maximum amount that you can make. So the maximum amount of that item that machine is for. So that's just to give some kind of constant value that you can work with to actually compare. And it also limits it to, how can I say, not go too high. So if you can maybe, for example, only make, like in that case, 40 shirts, like why allow it to make 400? Like, there's no need for that, actually. Okay, so the closer you are to your answer, the quicker it is to find it. But M, you can write as your max value, if you want to say it like that, the maximum amount of that item. Right? So Y is that specific variable that links the machine. So I'll write here for now. It depends on the scenario, but for now it's a machine. And these are your items, let's say number of items that are made. So your machine is bin, your number of items are int, and you're going to have a maximum amount that you can make. Maximum amount would refer to the items. So if your items are integers, you'll have to get the maximum amount in terms of the number of that you can make. But if the items were actually binary themselves, then you literally count up how many items can be chosen, literally. Like if I'm only looking at 3 items, whether they're going to be in my, let's say, knapsack, like the knapsack algorithm, whether they're going to be in or not, yeah, I count how many items because it's only going to be 1 or 0. So what's the max? 1, 1, 1, 1, 1. Okay, I'm just giving you some tips there. All right, but going to the maximum amount, how do I get to this constraint? Okay, so I'm going to show you how to set up the constraint, and then we'll play around with seeing that it actually works. Okay, so let me just go back here. I just want to make a new page. There we go. So if we go here, you'll see that we're working with xi less than or equals to myi. Right, let's start first with the shirts machine. Don't judge what I wrote there, shirts machine. So that's going to link the shirts machine to shirts. Right, so xi being the number of shirts and yi being the shirt machine. You have to link the correct machine to the correct items. So if there was maybe a machine that could work or that is rented for 2 different items, you'll have to link it to the 2 items together. Hear my words, together, not in separate constraints, together. I hope that gives you a bit of a hint there. Right, but sure is bin machine. I'm just saying bin from binary. Now I'm going to say, but how do I do that? Okay, how do I get the max value at all? So guys, the max value, you'll be looking at your other constraints. Do you have anything limiting it? If you have other constraints, they are being limited by either, in our case, labor or cloth. I don't know why I say cloths, but cloth. Right. So you're going to use your other constraints to check how much is the maximum amount you can make. You can always make the max value a bit higher, but you can't make it less. You don't want to restrict it too much. So if you make this max value 20, but the amount of shirts you can make is like a 40, then you're going to not be allowing your IP to get a solution with more than 20, which is wrong. I mean, what if 40 would have been your optimal solution? So don't restrict too much. Rather round up. Rather use a higher value. Okay, but how do we get that high value? You probably saw the answer already, but let's have a look. So if I want to know the maximum amount X1 can be in terms of labor specifically, then everything else is going to be 0. If I want the maximum amount that could be, then everything else needs to be 0, because then it will be that maximum. Right, so let's see. How many shirts can I make in terms of hours of labor? You can tell me. How many shirts am I limited to? Yes, 50. You're literally going and saying 3x1 plus 0 plus 0, because not making anything else will give me the maximum I can make of that item, because then you're not making anything else. Then it's the max of that item. Less than x 150, so if you divide 3 both sides, the maximum amount of x1 I can make is 50. So 150 over 3, well done. But that's just to do with labor. I still need to check the cloth as well, because cloth could be more restrictive. So you guys can tell me, how much for cloth? Very good. For cloth, X1 specifically, you're saying 4, X1, because we don't know how many, we're trying to figure out how many we can make max amount of. Plus 0 equals 160. Doesn't matter what sign you use, you're just checking how much is the max. And if you divide 4 both sides, X1 equals 40. Well done. So 40 items of shirts is the max we can make in terms of cloth. Why am I not saying 50? Because the closer you get to your answer, the better. You want it to be more efficient. But like I said, technically you can use the 50. It's not restrictive at all. But in the test, we want to see that you know the logic behind it. What's the max value between the two? The max value is 40. And the reason being is 40 is the only amount of shirts I can make with cloth. I can't make 50 shirts with my cloth available. I don't have enough cloth to make more than 40 shirts. So the max amount of shirts I'm possibly going to be able to make is 40, because my cloth is limiting me to not be able to make that 50, for example. Right, so 40 is your answer. If you want to make a note to say in this step, choose the smallest, I mean, go for it. But the whole idea is to say, I cannot make 50 shirts, even though labor allows me to make 50 shirts because I've got 3 hours per labor for a shirt, and I've got in total 150 labor hours available. And when I divide, I can see I can make 50 shirts with the labor I have available. That 50 shirts is more than I can make in terms of cloth, because with cloth, I can only make 40 shirts. So the most restrictive one would be your max value. It would be the closest to your answer in a sense. So this max value is 40 due to 40 shirts being the maximum amount I can make. All right. But obviously, we'll get back to doing this again with X2. All right. Anika, let's see. Let me first finish this one, then we'll come back to X3. But you might be right. So let's see. This one specifically is for X1, Y1, because it's a shirt machine, which is Y1. X1 is the shirts, and M is then the maximum amount. So it's then literally X1, less than or equals to 40, Y1. Don't leave it as is. You know standard form. All the variables must be on the left. Then it's less than or equals to 0. So that's how we get that constraint. Let's quickly look at X2 and then X3 to make sure we've got this. So for X2, let's get the maximum amount for X2. M for X2. So in terms of labor, what's the maximum amount we can get for labor in terms of X2? Let's see if the guys got this. Perfect. So if we're now looking at making everything else 0 and then dividing by that value. So it's going to be 150 over 2, which is 75. And in terms of cloth, how much over how much? Thank you, Danilo. Very good. So we're going to say 160. Oh, and Adrian, sorry, I missed your answer there. 160 over the 3, because we're now looking at X2, the rest being zeros to get the maximum of that item. So 160 over 3. So you get a 53.33333333333. Now, of course, we know by now we need to think in terms of integers, but remember, you only think in terms of integers when you actually solve with branch and bound simplex. So right now, I would prefer that you round up. So I'm going to say there, round up. Now, the reason being is you don't want to restrict too much. So if you made it 53, and it gives you an answer of 53.12, and now you do branch and bound simplex, you don't want to kind of restrict that too quickly. So rather round up in this case. All right, so I'm glad you guys thought ahead about that, but rather round up for this case, just to not restrict it too much. Okay, so rather go and say 54, no matter what the values are. All right, but on assessment queue, you'll see how we ask you to round, and then you, I don't like it, but then you can stick to that rounding. But my suggestion is always round up. You don't want to restrict too much. I'll accept that answer. So rounding up would be good here. It's just a max value to get closer to the answer. It's not saying that that's going to be your answer. I mean, you still have to solve all of this. It's just the IP. Okay, you don't want to restrict too much, and you don't want to give a too high value, because if you give a value that's too high, it's going to take longer to get to the correct answer. The closer you are to the answers, the shorter it will take to actually get the correct answer, the less iterations or pivots. All right, so you want to try to get this max value, but then you can round up just to get a value not restricted too much. Okay. Now let's see, Anika. Let's check quickly X3. So going back up, what are the values for X3? So 150 over 6 is what? I also had to check now. 150 over 6. 25, yes. Anika, you got it. 25. And the other one? 160 over 4 is 40, so you'll take the 25. Very good. Yes, yes, yes. So guys, just to make it clear what Anika was saying there. So for this one, let me just redo. So just to make it clear again. So let's see if I can erase without touching the colors much there. I'll write it again, it's not a problem. But just to make it clear. Right, so going back here, we say, okay, that's x1 plus those two for x2 and those for x3. So if we go and look specifically for labor, you would then go and say, okay, for x3, what's the max amount of labor? So that means everything else will be zeros. So you divide literally by 6. So you go 6x3 equals 150. You say 150 over 3 is x3. We might ask you to leave it in fractions so that we don't round. That's maybe a better option, to be honest. Much better option there. I'll give that suggestion to whoever sets the test. But then you'll go and you say 666 over 66666. That gives you a 25. So x3 equals 25. All right. I'll send a message, but there's unfortunately nothing I can do at the moment. Literally nothing I can do. But I'll stop and let you take a picture if you want to. Yes, that I can do, definitely. Yeah, give me some suggestions. I'll make it work with you. Please give suggestions if you have. I just can't do anything right now about the network. In slow motion. Wow. Okay, I can try that. I'm just sending a message again. Yeah, the lag might make it worse than it already is. Very true. Okay, so maybe, but I'll try to write slower, right? When I erase, I'll do it quick, so it's very quick, you know, like yo. But when I want to erase, I'll stop for a minute. Okay, let's just go there on x3 still for cloth specifically. So let me write here cloth x3. So they're 0 for everything except x3. So that's going to be now 4x3 equals to 160. Then you're going to have 160 over 4 for x3. And then the answer for x3, which is the max for cloth. Let me just also make sure that that's 14. Okay, so I'm giving you a chance to let the writing pad catch up, but which value between 25 and 40 should we select? Which value between 25 and 40 should we select? But yes, 25. Guys, remember you are saying in this case, I can only make 25 pants with the amount of labor I have available. So using the 40 for cloth, yeah, sure, you can make 40 pants with the amount of cloth you have, but you can't make 40 pants because you don't have enough labor. You only have labor enough for 25. So you have to then choose the 25, the smallest value. So yes, Anika, you were 100% correct there. Okay. So that's where these values come from. I'm just going to go back. Just if you were making like taking pictures or something, there's your x3 one. And then we're going to now test how these constraints actually work, and that they actually do work, and that they actually make sense. Let's see. You guys good so far? Even though you don't know exactly how the constraint works yet, but are you good so far, seeing the M value? If not, of course, you'll then have to go play around with this to see how to get the max value. It's just a bit of algebra there, functions. If you get your intercept, you get your max value of the other variable. It's basically just linear in a sense, linear functions. Okay, good. Let's see how these work. Just want to double check. Are you guys still with me? Like literally with me? Like that's what I meant. Like you're still here. It's so quiet now, so I'm not sure if I'm lagging. Okay, thank you, Andre. See, you're always very quick to let me know. It helps a lot. Otherwise, it gets very silent, you know? Because even though I can check the webcams, I don't want to open it and make it even slower. So, I'm just in silence here, cold, yes, very cold silence. All right, let's see how these would work. Okay, so I'm going to help you quickly understand how they work. But what's your formula for linking constraints? It's literally the x, and it's less than or equal to always, even though technically you should be setting this up on your own. But, there's your help. A max value and the y that you are trying to link. So this is what you are trying to link to which item. So you're linking that, let me write the link fixed cost to that specific item or items. Could be items. So guys, if you had more, let's say we had one machine for two different items, because they could be let's say a certain machine can be used for different items. Then you would literally go and specify which two items, because it's still xi, so which items. So maybe it's item 1, which is shirts. No, let me rather say shorts and pants, because they're very similar to the same thing. So maybe shorts and pants, you would then go say, for these two machines, I'm then going to use that max value for that specific y. Right, which machine is it? So if you called it y2, then you'll be using y2. You won't have separate constraints, because it's either you're going to make one of these or both or none that will then affect that y. Right, not separate. Hear me again saying this. You're not making separate constraints if they're using the same machine, because that's pointless, because it won't work. Reason being, that machine is linked to both of them, not one or the other, but both. So it should work for zeros, ones both, or this, or this. Or a 20 or a 30, anything should work for anything, but as long as you include them both, because it's literally for both of them. Okay, I gave you that hint, but I'm not going to go into more detail, because that's a hint. Where's Manisha with my hint, wink, wink? Right, so that's just a hint there. For the max value, you'll have to apply a bit of logic there, right? But I'm not going to go further. So going back to these constraints, let's quickly go back here. Let me know if you want me to stop. I'm not erasing, so if you want me to scroll down or up or something. I just want to go see the constraints again. So 3, 2, 6, and 150. And then the other one was 4, 3, 4. Then objective was 647. And the other values was 200, 150, let me see, 200, 150, and 100. It's not a cube, sorry. Okay, now we want to test this out and see how they work. So I'm going to focus specifically on this new constraint for y1. So we said 40 was our max value there for that one. You remember this one I said you can round, but I would rather have you round up. That's a bit more preferred. So let's see. Why do you not want to go back? There we go. Okay, so let's see how we do that. But if you can leave it as a fraction, that's better. All right, let's see. That is now 40. Let me write x1 minus 40 y1 less than or equal to 0. So all that I did was, so just to make it clear, I took that 40 y1 over. It becomes minus 40 y1 less than or equal to 0. So that's where that comes from. Okay, so let's see how this works. So I'm going to play around with it a bit to just explain the concept. I'm not saying you should be doing this. It's just a good idea to. Otherwise, I don't want you to parrot this. You need to understand that you need to be able to make constraints like this. Right, so let's see how this goes. So let's say we are making, not a pencil, x1 equals 0. We are making no shirts. Remember, this is specifically for shirts and the shirts machine. So y1, and that's x1. So we're making 0 shirts. Now you guys tell me, should the machine be rented? Should the machine be rented? No, the machine should not be rented. Well done. No. Okay, let's see if it works. So if I put a 0 in there, now I'm going to start with y1 for 0, then we see if that would be allowed. Okay. Zero minus something times 0 is 0. 0 less than or equal to 0. Is that true or false? True. So it's allowing the machine to stay 0. Now it usually starts with 0 because you're trying to maximize. So it will not subtract the cost if there's no need for it. So it will only change that y to a 1 if it's really necessary. So right now, what's happening, this y is a 0. That x is a 0, that's not a problem. I mean, if that was the answer, then so be it. But the y is a 0, which is great, because you should not be subtracting the rent for that machine if you're not going to be using or making shirts and then using that machine. So anything times 0 is 0, so that cost will not actually be subtracted. All right, let's play around more. Let's try the next one. What if we make, these are a lot of ifs, just to make it clear, I'm playing around with I'm testing the constraint. So what if we make x1 equals 10? Should the machine be rented? If we make 10 shirts, should the machine be rented? The shirts machine specifically. Anyone there? Yes, thank you, Adrian. So if you're making 10 shirts, yeah, then you have to be renting the machine. You can't be making shirts without the machine. So you actually have to pay for that machine. Let's see. Now, I have to listen if you can't see every minute, right? So we're making x1 10. If x1 is 10, I substitute 10, and we say minus 40 times 0, less than or equals to 0. Would 10 minus 0, which gives you a 10, be less than or equals to 0? Would 10 be less than or equals to 0? True or false? False. Well done. Guys, 10 is not less than or equals to 0, so that's a false there. So what happens is it then sees that y1 is not possible to be a 0. It's false. It's restricted. It can't be 0. So what then happens is it then goes to that y1 and changes it to the other value. Y1 is binary. It can only be 0 or 1. So it then changes it to a 1. Of course, if you don't get zeros or ones, you have to then do some branch simplex, hint, hint. But anyway, it changes it to a 1. Now that it's a 1, now let's test. Now it's going to be 10 minus 40 times 1. So 10 minus 40 is, yes, true. That was very quick. But 10 minus 40 gives you a negative 30, which is definitely less than or equal to 0. That is true. So it says that it would only allow this if y1 is equals to 1. Now what happens in our objective function? It says that now we have 10 shirts, so it substitutes that 10 in. So it tells us that it's going to cost us 60 Rand, not cost, give us a profit of 60 Rand. But then we have to subtract the cost of the machine, which is then going to be 200 times that 1. So it's going to be 60 minus 200. Now, that's not the final answer. Remember, it depends on your x2s and your x3s, all of that as well. But I'm just saying that's technically what's happening. Right, now my last check. What if I make it more than my max value? What now? Let's see. So making x1 equals, let's make it 50. So if I make it 50, let's start with the y being a 0 again. I told you that it will only make it a 1 if it's really a must. So I put a 50. I see Adrian is already typing there. 50 minus 0. $50 minus 0, less than 0, true or false? True or false? I keep on asking because I need to know that you guys can still follow. True or false? False, well done. So that's going to be false. So it's going to force the y to be a 1 instead. So now it goes and change the y to be a 1. Whoops, 40 times 1, less than or equal to 0. 40, 50 minus 40 is a 10, less than or equal to 0. Is that true or false? Ten less than or equal to 0, true or false? False. And that's perfect. We don't want that value. That value should not be allowed no matter if y is a 0 or a 1. Because we can't make that amount. Our max value for x1 is 40. We can't make more than 40, so why allow it? So if this is false and false, sure, it's not going to allow it. So just to make a note for the more difficult constraints, if one of them is true, it's going to allow it. It's just going to, it's like a switch statement. It's going to switch. Crazy. That's weird. Okay, but as long as you're back, Adrian, it's good. Right, so your y can be either 0 or 1. So it's going to switch between 0 and 1 for your y. So if one of them is true, then I'm going to make the y that specific value. But if none of them is going to be true, nothing, not even the x value is going to be allowed. So as you can see here, both are false. So if both are false, it doesn't allow, let me just use a red here, doesn't allow the 0 here for y1, doesn't allow 1 for y1 because it's not working for the x value. So even that x value is going to be a big no. So nothing in that case will be allowed. So that will not be a possible answer, which is perfect. With these conditional constraints, you have to make sure you allow what should be allowed and you restrict what should not happen. So that's exactly what we're doing with these constraints. We're first of all creating a link so that the y becomes a 1 if, sorry if I circle too much, it erases, if I actually make that a certain amount of that item, so it changes it to a 1 because that becomes true. So that's perfect. If it was a 0, then you should not be paying for that machine. So if it can stop highlighting, that would be better. Let me do this. So it's going to leave the y as 0, and that's true because you should not be paying for the machine. So that works perfectly fine. It's not going to make the y a 1. But in the case of having an x value that's higher than your max amount, it will not work for y as a 1 or a 0 because it cannot take that amount for the x anyway. So it will not work for either or. Right, but that's how your constraints work, right? Obviously, you can go play around with other values to see it more clearly. But just to show you here what happens if you actually include those values, sorry, I went a bit too far. What actually happens is you'll see here x3 is equals to 25. So which machine, if x3 is pants, which machine should be rented? Y1 for the shirts machine, or is it Y2 for the shorts? Thank you, Conrad. We're renting the pants machine, so we need to actually have that as a 1 because we need to rent it because we're making pants. Is it? Yes. For the other two items that we're not producing, we should not be paying for those machines, so the machine should have a 0 to multiply it with a 0, and that worked out perfectly. Right, but you need to include the constraints for all the machines, otherwise there's no link and those values will stay 0 no matter what. So these linking constraints are extremely important. Right. Now we got some trickier constraints that we're going to play around with. I'm going to show you, and then you'll be able to try your own exercise there. But these are what we call either or constraints. Now, just to make it clear, they are on BC Connect. I think it's called logical constraints. I'm just quickly opening BC Connect on my side to also just see. So they're under logical constraints. There's an Excel sheet there to help you with some other kinds of constraints, because obviously if they're logical constraints, I'm not going to show you every single type of constraint. That's not possible. It's all about you setting up constraints that will fit all conditions. So like we did last week with the capital budgeting, it doesn't mean they're going to look exactly the same every time. I mean, you saw now where we had some variables as binary and some as integers. And now integers required a max value, whereas binary didn't have that. Binary, you simply multiply with a value. But guys, it was also a max value, just to throw it out there. If you had a binary constraint with x1 is on both x2 and x3. I don't know exactly what this should be, but both x2 and x3, you had to multiply this x1 by 2 because that's the max value, 1, 2. There are 2 of them that is based on that one. So that's the max value. I'm hinting towards it's actually the same, right? So even if it's binary, you just count them up to say that's the max value. But for int, you have to calculate the max value. Right, but please go to those logical constraints. Go through them. There might be some of those that pop up that you might need to set up. And then you already went through it and you already have a quick idea how to set it up instead of trying to figure it out. So it's just there to actually help in actual fact. But those logical constraints are part of the rest of the IPs as well. All right, now we're going to do this one. I just want us to stand up and stretch our legs or something before we tackle this one. So I'm just giving you 5 minutes quickly just to breathe, and maybe if you wanted to quickly go grab some water or something. So let's just make it, till 30. Just to breathe and stretch our legs, 7 minutes. There we go. I hope that's okay. If not, let's get through it. But I just want to check, can you guys hear me? Are we still good? You can see the screen. Are all of that still good? Thanks, Yandre. Right, thanks. Okay, let's see. Either or constraints. Let me scroll down. Vian, so you can use any large value for the max value as long as you're not restricting the amount too much, meaning if our maximum amount was 40, you could use anything higher than that, because then it won't limit your maximum amount more than what you actually can make. But we tend to try to use the exact amount. So in a test, I would expect you to give me the exact amount, not just a high value, like the exact amount, because I want to see that you know how to get the maximum amount. And the smaller that value is, meaning the closer it is to the actual maximum amount, the less iteration it will take to get to that value, or the correct value, if that makes sense. So I hope that works. So you can use any large value if you're like, I really don't know how to get this maximum amount, although it's very risky, because what if you could make 210? Then that 200 would have restricted you not to allow 210, which could have been your optimal solution. But I'm just saying, you could use anything. It's just the closer to the max value, or the max value itself would be perfect. In a test, you need to be able to give the max value on the dot, right? Awesome. Okay, so either or constraints. Let's see how that goes. Just answering someone quickly. Okay, cool. Just help someone quickly. All right, either or constraints. So these are a bit more tricky. They're not as easy as what we had in capital budgeting, and that is purely because we are not working with just binary. Right, you saw now that x1, x2, x3, they could be integers. So it's not as simple as binary where you literally went and said, okay, between x1 and x2, either or. So you literally went and said, okay, this should be true, this should be true, that should be false, and this should be false. And you played around with setting up a constraint for that. It's not as simple as that, because now you're working with something like pans, which can be any amount. We have a max value, but below that max value, any amount could be the answer. We don't know. Unless if we solve, of course, but we don't know yet. Okay, so we have now that scenario where I said they could introduce it, and then I said we'll talk about it later. So let's see. All right, so what they're asking for is, if pants are made, just give me a minute. Okay, sorry about that. So if pants are made, so if x3 has a value, meaning any value, we don't say what value, if pants are made, more than or exactly 20 must be made. So basically, this is a justification to say that if they're going to rent that pants machine, they want to at least make 20 or more pants. Does the statement make sense before I continue with how to get that statement into a constraint or two? Does the constraint make sense? Just want to make sure you guys still with me and following and can hear me and see, because it's dead quiet. Cool. So we have basically, just to recap, even though you're saying shop, if pants are made, so if pants are made, number one, we have to pay for the machine. But we have that constraint, that's sorted. But now we have an additional part to say, if pants are made, more than or exactly 20 must be made. Usually we say more than 20. Then you should assume that we're actually including the 20, because remember, we only have greater than or equals to signs here with linear programming. If you want to be specific, you can say 20.00001 or something, just to make sure that it's greater than 20 if they said more than only. Okay, I will also accept that. But anyway, going back to this, if we say more than 20 must be made, so it's some kind of justification to say that if we're going to make pants, we don't want less than 20. Like, why bother paying for that machine if we're going to make less than 20? All right, so that's the idea for this. Now, how do we set this up? Now, I made some kind of like formula constraints there at the bottom to help you set up either or constraints. Make a note, either or, not a linking constraint, not just a normal if, but this is either or. So just to explain why this solution or this scenario is either or. So we're saying if pants are made. So if x, in our case, pants is x3. So if x3 is more than or equals to 0, we want to make sure that it is supposed to be more than 20, just by the way. So if it's more than equal to 0, we want to make sure that it's not going to be that value, though. It's going to be actually more than or equals to 20. So that's not going to be allowed. We want it to be more than or equals to 20. But if it's not more than or equals to 20, guys, what should x3 be? If we're not making more than or equals to 20 pants, what should the answer of x3 be? Sorry, x3. Think about it. What should the answer of x3 be if we're not making more than 20? Well done, Andipa. Well done, and Conrad, everyone. Well done. Then you don't want to make pants. If you can't make the right amount, you should not be making it. So it's either this or x3 should be equals to 0. So you can say less than or equals to, but either or equals to 0 is what we're looking at. Okay. Now, can we have both of those constraints? Will we have a feasible solution if we put in both of those constraints? So you can put it like x3 greater than equals to 20 and x3 less than or equals to 0. Or equals 0, doesn't matter. We just tend to avoid equals because of those split constraints. But can we have both of these constraints? Think logically. Will it be feasible? Can you have an answer for x3 that's greater than 20 as well as less than 0? Because if you're putting both constraints into your IP, it needs to be both of them. So even though we're logically saying it's or, when you put both constraints, it's going to be and, because you have both constraints in. So no, it's no. You're going to have an infeasible solution because x3 can't be less than or equals to 0 as well as 20 or higher. It's not possible. So do not put those constraints in like that. That's definitely not correct. It will make your solution infeasible. Because if you're writing your constraints and you go like, you're saying both of these statements must be true because every single constraint must be met when you solve. Every single one of them must be met when you solve. So you can't have it as these constraints. Not possible. Will it help to do the following? Will it help to go and say x3 greater than x0 and x3 less than or equal to 20 or and, it doesn't matter what word I use. Will that make any difference? What will happen if I put those two constraints? Give me an answer or an example. What will x3 be? What will happen? It's possible, but what's the problem? Yes, Anika, x3 can then be anything between 0 and 20. Is that what they're asking for? Is that even what they're asking for? No, they're asking for if we make pants, they have to make more than exactly 20. That's just saying x3 can be anything between 0 and 20. Right. So yeah, exactly. We want more than or exactly 20. That's not gonna, no. Can I then just put a constraint saying x3 greater than x20? Would that be fine? Would that even work? For the whole if. Thank you, Anika. No, there's an if there, right? If you go and put that constraint, you're literally just going to make the answer of x3 greater than 20. You're never going to allow it to be able to be a 0. Never. Okay. So no. It's an if. You can't just go and say, we want more than 20. Just said, if you make pants, then we want more than 20. But if you don't make pants, this should be perfectly fine. Now, how do we set this up? So we've got these, how can I say, formulas for constraints for either or specifically when you've got something like it can either be this or this, but not both at the same time. Not, do you hear me? Not both at the same time, because you can't have it as 0 as well as 20 at the same time. So you want either this or that, then you know, okay, let's follow this kind of formula, right? It will stay the same. But if you have a way to set it up to get the same, go for it. All right, but let's have a look. What can we work with? Okay. So let's set up the constraints and then I'll show you exactly how it works. But for these constraints, we need the max value like we did before, which we already saw how to get. That 25 we got before. We need to know what are we setting it in terms of either or. So either it's going to be less than 0 or it's going to be greater than or equal to 20. So we need to know that. Then we're going to need some dummy variable to make it work. So you literally, dummy variable does not add any value in terms of your answers. It just helps this constraint work. Meaning it makes sure that it's going to look between these two constraints and check that it's either that one or that one. So I'm going to show you exactly how it works. But it's going to go between them and switch. Kind of like make this one 0. If it doesn't work, make that one a 0. If that doesn't work, try 1. So it's going to switch between them. Right, but you need a dummy variable that's binary. Okay. Technically, integers could work for the dummy. Technically, it doesn't matter, but I'll show you with binary because it's easier to understand, and you can use binary for the rest of your life. All right. Let's see, how do we work with this, and what do we do? All right. Now for these two constraints, you see I say U that I refer to as upper value and L I refer to as lower value. Okay, so between the two, the x3 less than or equal to 0, that's my lower, and the x3 greater than or equal to 20, that's my upper. So make a note of that. So my upper here is going to be a 20 and my lower is going to be a 0 to say what should it be less than or equal to 2 and what should be greater than or equal to 2. Right, so your lower can be anything. If we said less than or equal to 5, then your lower is 5. Right, so if we said something like if pants are made, more than or exactly 20 must be made, otherwise not more than 5. Then you're basically saying greater than or equal to 20 or less than or equal to 5. Then your lower changes to a 5. Just to make it clear that the lower does not have to be a 0. Right, it just depends on what your if statement is. So lower is 0 in our case because that was the statement. All right. Now we say, but what do we do with that? Okay, so which x variable are you working with? It's pants. So we say x3. Then minus upper times 2. So our upper is 20. So times 2 is a 40 then. You can write it out by saying 20 times 2. And then we're going to have some kind of dummy variable. Let's call this dummy 1 because we don't have any other dummies. Right, this is our first dummy, so we call it dummy 1. Here it doesn't matter if it's constraint 1, 2, or 3. It's just your first dummy. It doesn't make any difference. It doesn't put a slack, nothing in terms of that. It's just a dummy to make sure these constraints work as either or. Okay, but remember the dummy is either 0 or 1. Less than or equal to your lower. Nadrian. Then your lower value is a 0. And then you have to have your other constraint. So minus x3 plus this time. So your upper is going to be times 2. So you can say times 2 there. Can I press undo? No, apparently not. Let me just erase. Let's see. So you're going to say here 20 times 2. That gives us a 40 with a dummy. Now here, be careful. The dummy must be the same dummy. All right. Otherwise, it's not going to switch in between them. So for the specific constraint that you're setting up, it must be the same dummy. All right. So if you have, let's say, another statement like if shorts are made, make more than blah, 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 blah. Then you're going to have 2 more constraints for shorts. And those 2 constraints need to have the same dummy. But not the same dummy as these 2 constraints, right? So this dummy is specifically to work between these 2 constraints. So that should be the same dummy. Dummy 1. And then your upper value of 20. Okay, so I'm just creating these constraints as is. Now, technically, you would have been making these 2 constraints, which is quite hard. So that's why I gave you kind of like a formula for either or. And specifically either or with integers. That's why it's so hard. Okay, just to make it clear, either or with integers. All right, because x3 can be any amount, but we want to then make sure that if it's any amount, it should be more than 20 or none at all. So it's not purely just zeros or ones anymore. It's now integers that we're working with. Okay. So let's see how these constraints work and see that they actually do work and that we didn't waste our time. So I'm going to write it on my journal here. So let's have our constraints, x3 minus 14 d1 less than 0, and my other constraint is minus x3 plus 14 d1, same dummy, less than or equals to 20. So just to make it clear, this is specifically if pants we make greater than or equals to 20, and then even though they don't specify, that just means if we make pants, we have to make that amount. Otherwise, we have to make none. So I'm going to say otherwise less than or equals to 0. So if we make none, that's the idea. Okay, now let's see how this works. So it does take a bit of practice. We don't ask you to test it normally, even though we can. I'm not saying we're not going to ask you. I'm just saying we don't normally ask. We normally ask for the constraints. But I mean, we can ask you to test this because it shows us your understanding of the constraints to see that you can set up your own, hopefully one day. But to get to that, let's see. How does it work? So I'm going to try to show you the best possible way possible. It's very hard to actually understand, so I'm going to try my best to show you. Okay. So let's start off with 0 for x3. So x3 equals 0. Let's start off with that. Let me use red. So should this be allowed, guys? Should x3 equals 0 be something we allow? Let's see if I can erase. Does it? Nice. Yes, it should be allowed because we said if we make pants greater than 20, but if we don't make that amount, then don't make pants at all. Right, that's basically what we're asking. So this, yes, should be allowed. Should be allowed. Now let's play around and see if it will be possible. All right. So we start and we say, okay, let's substitute 0 into x3. So in both equations, x3 is the same thing. It is 0, right? Then both equations, d is going to be the same. So you can't have d in the one equation as a dummy, and the one is a 0, and in the other one is a 1, because it's the same variable. It's like saying x3 is 0, and now I say it's 10. That's not how an algorithm works. It must meet all constraints, and the x value is one answer. One answer. Right? If you get multiple answers, then you're going to have different solutions, but not at the same time. That's not possible. All right. So now we're going to say, okay, that's plus 14 times some kind of dummy, but the same dummy. That's less than 0, less than 20. Okay, so now let's try. Now I showed you before it normally starts with a 0 first because it tries not to have anything additional in terms of costs. However, it's probably going to play around because x3 equals 0. That's not going to give you a profit, so probably going to want to force you to make something. But let's see. All right, so we start with zeros for a dummy one. Let's see first what happens. So for our first constraint, is it going to give you a true or a false? 0 minus 40 times 0 less than or equal to 0. So 0 minus 0 is 0, is 0 less than or equal to 0. True. Yes, true. The next one, is it going to give you a true or a false for the next constraint? Minus 0 plus 40 times 0, so 0 plus 0 less than or equal to 20. True or false? 0 plus 0 less than or equal to 20. Sharp. True, sharp, true. I like the sharp. That's easier. True, right? If they're both true, it stops and says this is perfectly fine. So both true is going to allow whatever you put in. Okay, I'll explain this concept very soon. So both are true, so it's going to say, yeah, this 0 for x3 works perfectly fine. So it's going to allow it. Okay, now let's make it more difficult. And now we go and say, but what if x3 was equals to 10? Now I ask you guys, should it be allowed? Should x3 of an answer of 10 pans be allowed? No, no, don't. No. Okay. It should not be allowed because we said if they make pans, make more than 20. Otherwise, we don't want anything. Okay, now let's see how it works. So we still have x3 and our dummy. So we go and put 10 into x3 everywhere where we see x3 in our formula. We put our formula values, great stuff. And then our dummy, we start with 0. Start with 0. It doesn't mean it has to be 0. I'm just saying if your dummy is 0 for the one, it needs to be 0 for the other one as well. Okay, let's try it. Let's see if zeros for the dummy would work and allow it. So first constraint, true or false? 10 minus 0. Let's make it to 0. True or false for the first one? See, no, no, no. False. If 1 is false, guys, it is false. It will not be allowed. If 1 is false, no. So 1 false will not be allowed. Whatever you put in will not be allowed. Let me just say not. Will not be allowed. So you don't even have to check the other one. What we'll do it just to show. Will the second constraint be true or false? Sharp, it's going to be true. Because minus 10 plus nothing is less than or equal to 20. I mean, minus 10 is less than or equal to 20. So it's going to be true. But as soon as one of them is false, it's not going to allow this so far. But it doesn't mean it doesn't allow the whole thing. It just says that the dummy with 0 is not working. So what it's going to do is it's going to change the dummy to a 1. And then check if there's any possibility of that working. So now we try again. Okay. x3 is still 10. The formulas don't change. It's still the same constraints that we have. But now it changes your dummy to a 1. So your dummy becomes literally a 1. Remember, your dummy has to be the same in both constraints. You can't have 1 as a 0 and 1 as a 1. It's the same variable. You can't have different stuff for the same variable. It's not possible. Okay, so your dummy is 1 for both now because it's not possible to have different in both of them. Okay. Now let's see. For the top constraint, will it be true or false? 10 minus 40 less than or equals to 0. 10 minus 40 less than or equals to 0. True. So 10 minus 40 is minus 30. Minus 30 is less than or equal to 0. So that's going to be true. But what about the other one, guys? It's going to be true or false? False, very good. Minus 10 plus 40 is a positive 30. And 30 is not less than or equal to 20. So it's going to give me a false. If one of them is false, no, it will not be allowed. Will anything then be allowed in terms of x3 equals 10? No. Changing the dummy to a 1 instead of a 0 still does not produce both truths. So both of them must be true before that x value is allowed. Both of them. It's like I need a true before it's actually true. If there's one false, change the dummy. If there's still one false, then that x value will not be allowed. Now let's try it with another one. So the last one, then we'll take a break. So let's try x3 equals 30. Should that be allowed? Should 30 pans be allowed? 30 pans. Should it be allowed based on our initial statement? Yes, we said if bands make more than or equals to 20. Okay, so 30 should be allowed. We need this to be a yes. Okay, let's see. So just using our formula, x3, d1, we're going to start with 0 and then change if it doesn't work. So we have substitute, okay. 0 less than equal to 0. Minus the 30, if it allows me to write there, plus 40 times 0. So dummy must be the same for both. You can't have a 0 in the one and a 1 in the other one. It's the same variable, can't change. Okay, now let's see. 30 minus 0. Is it less than or equal to 0, true or false? Yes, please, Anika. Obviously in a test, you leave it until you have time to test. You can see the patterns, especially in that Excel sheet I gave you. Like look for patterns that if it's either or, then you're going to do these two constraints. If it's binary, you're going to do this. If it's location, you're going to do this. So you can memorize if you want. But I mean, it's better to do instead of memorize, because then you might not make a mistake with a plus or a minus, right? So because, for example, you'll see both of our constraints are less than or equals to. And in a test, logically, you're going to be like, oh, less than or equals to 0, greater than or equals to 20, and then you're going to make one less and one greater, which is not the case. So, yeah, if you can test it a bit to make sure that you actually have the right constraints, then at least you know your answers are correct. If you don't have time, put them in, continue, come back, make a flag or something on assessment queue so you can come back and test if you do have time. Otherwise, just put in what you remember. Okay. But going back in, what is 30 minus 0? Less than or equal to 0, is it true or false? 30 minus 0 is still 30. So less than or equal to 0 is going to be false. Conrad, yes. Yeah, you can do that. I just want to show the concept. I just want to show the concept that it will switch then between the two. But yes, if you see the idea that, yeah, you're going to need the machine. But please don't mistake the D with the machine in terms of the variable. Right, guys, you cannot make this Y1, okay? So if you made this Y1, yeah, sure, Y1 is binary, which would help you make these constraints true. But if you check this one, where can I put it? Okay, I don't have an example that would work with it right now. But if you make it the same and the dummy should allow it to be a 0 to make it work, but you need the machine to be paid, then the machine is also going to be 0, which is going to be the opposite of what you want. So please, the D is not the same as your Y. Don't use your Y here. But the idea, the concept that you have, Conrad, is perfect. Okay, the fact that you're going to have a machine, so that dummy is going to also be a 1 then, so it will work out, and you can immediately show that. That's perfect. All right, but just to show the concept, guys, if one of them is false, it will not work. So even though minus 30 plus 0 is less than or equal to 20, there's one that's false, so no, it switches the dummy then to a 1. Okay, so now it goes, so just to show you, it switches the dummy now to a 1 here. So minus this, but the dummy is now a 1. And plus 40, 0, less than 0, less than 20. So there, 30 minus 40 is going to give you a negative 10, which is going to give you a true. And then minus 30 plus 0 is going to be literally minus 30. Less than or equals to 20 is going to be true. So what happens here is it allows them both, meaning both are true. So it's going to be at the end literally a true. Whereas if one of them is false, in the end it sees it as a false there. So it is true if the dummy is 1, but in actual fact, it is true for both. So if both of your constraints are met, then it means that value is allowed because both of them are met. Even though the dummy is the same thing, I don't know why I wrote a 0 there, even though the dummy is the same thing, it's still going to allow it. Thank you, Conrad. I was like, you were thinking the same as me on the moment. Right, minus 30 plus 40 is just a positive 10, so it's still true. Right, but yeah, that should be 1. Please, dummy should be the same for both. Please, 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 just want to erase this. Can it erase? There we go. So both true, meaning it's going to then allow that value. But I want you to see that the dummy must be the same thing when checking both at the same time. If one thing is false, like in the first two that we did with the 30, then that dummy is not going to work. Then it checks it dummy with a 1. If both of them are true, yes. If one of them is false, then also still not. Then it went both possibilities and said none of it works, so no. So like the one where we said x3 equals 10, none of it worked. There were no true on either or, so nothing was allowed there. So it's basically like saying either or. So either the dummy is going to be 0 or a 1. If that's not working for either or, then it's not going to be allowed. So that's basically what happens. Okay. But please do not make the dummy a y, because then if something conflicts and it changes your y variable, that's not what you want. Right. Kenneth, you're saying bottom page 3. Now I'm like, page 3. Let me see. I'm just going to click rather. That's going to be faster. Kenneth, this bottom, is that what you want to see? Just give me a shop or a no more or something. Cool. Conrad, yes. So anything between 20 and 40 will work. So guys, what Conrad has asked is very important. I mean, we have a max value of 40 in our other constraints, right? And so even if you go higher, your other constraint is already limiting you to 40. I think it was 40. Was bands 40? I can't even remember. Oh, is it 25? Okay, so more than 25 won't even be allowed. So you can't even go further than 25. But that's because of your other constraints, right? You already have your linking constraint saying that x3 can't even go higher than that. So if you have other constraint restricting as well, it's also good to have it, right? No, don't worry. I was also thinking the 40 because of x1, but yeah, you're on the right track. That max value that you have from your other constraint will help you not go past that anyway. Because remember here you said your max value is 25. No. Not that you need it in these two constraints, but yeah, it's limited by your other constraints. It's even limited with your cloth and your labor constraints, but yeah, it will definitely not make more. So even if it's allowed, your other constraints will not allow it. Ken, if I switched so quickly, like, are you good now? Just want to make sure that you're good. Conrad, your other constraints are limiting it. So it does not, in these constraints, we did not include that 25 anywhere. Right, so this M tells us how much is the max, but we didn't include it in these two constraints anywhere. You can't really include it anywhere. So it was actually limited with your other constraints, your linking constraints or your cloth and your label constraints. They limited to 25. But on these constraints, we never use the M value, so it will not restrict it in these two constraints. You can change the upper and your lower values to try and make that happen, but then you still have to make sure all conditions are met, right? So you can try to make that happen. It should be possible where you play around with your upper and your lower. But this is the idea, right? So that if you do this, this will still work because you have your other constraints that already limits it. Okay. Yeah. Because of playing around with it, that would be then the max value. So it's just making sure that that upper value is going to be possible. I'm going to say no. Yeah. But let me see if we go. Yeah, 40 minus, no, wait, Conrad. If we go and we say 40 minus 40, you're going to have 0. Minus 40 plus, wait, 4, let me sort the, if this was a 40, and this is a 40. 40 minus 40 would be a 0 there, and minus 40 plus 40 will still be 0. So you can even go more, but yeah, because of your labor constraint and your other constraints, yeah, you can't go. Well, in our we keep on going saying 40. So it's not just you can run, I'm also saying 40, but 25. Yeah. Right. But let's take a break. I owe you 15 minutes, so we'll be back 10:25. So I'll see you 10:25. Me. Hello. Thank you. For this one, we are technically done. There's an exercise there that you can practice, obviously for homework. We're going to continue with the location IP, and then if we finish quickly, I'll give you a chance to do the exercises. Right, but for today, it's fixed charge, which we've done, and location IP, which we're going to start with. Tomorrow, it's set covering and knapsack, and then if we get a chance, we'll come back to some of these. And then on Wednesday, we'll go through the knapsack exercise, and I'll decide whether we'll do a review or first do the topic, and then maybe on Thursday review. Right, but we'll see how it goes. But we'll probably stick to the study guide to make sure that we follow, just in case someone misses. All right, let's see. Closing this, with your exercise, it's in the slides themselves. They are more on the PDFs. Vian, probably on Wednesday, just check the study guide, whether I say there, and then we'll follow that. I just haven't looked at it yet. But I'll open it when we review, and I'll make an announcement I normally do. So yeah, this is my test, so I'll make an announcement. For the next one, it depends on when the lecturer opens it. But check announcements always, by now probably. Okay, let's see. Location. So our next IP location. Oh, thank you, Andre. Thank you. Just check the exercises on that, presentation, PowerPoint, and then on PDF for any additional exercises for fixed charge. Okay, you should see on my screen now, location, specifically the lockbox problem. Lockbox. So it is literally a specific kind of problem, okay? Although it will follow the same principle if you have another lockbox type of problem. But the idea here is the fact that you have some kind of place where something will be stored or kept, and you're going to pay a certain amount for that, in this case, that lockbox. So you're not going to pay for the lockbox if you don't use it. So it's a specific location. But if you use it, you're going to pay for that lockbox. That's basically where it is. Is there no location topic there? location or something in that line. Yeah, I think it says location on it. No problem. As long as you ask and don't stay quiet, then I'm happy, right? But yeah, location. Cool. All right. Just make a note to check the, does it say, is there a tab logical constraints? Just double check for me for that. Tab logical constraints. Because there should be stuff there to help you with all kinds of logical constraints, which we don't go through, but you need to practice and set up and see what fits where. Okay, cool. Thank you, Joanne. Thank you, Liam. Thank you. Cool. So make sure you go through those. All right, let's see. The lockbox problem. So a very unique type of problem. Now, it's like I'm going to talk in terms of literally cash, but it's not really cash, right? But let's say customers want to bank their money like their cash, then that cash would have been sent to what we call a lockbox. And then that lockbox is where it would have been processed for the bank. Just an example, right? But it's more to do with, okay, there's some place where it gets hauled up. And as it gets hauled up, there's interest that could have been earned on that money, which is not being earned. So that's the concept. But the main idea is if you're going to have a lockbox, you have to pay for it. If you're not going to have a lockbox, you don't pay for it. So it's very similar to the example we just did, except it's going to be much more binary than integers. Right, but let's have a look. How do we set this up from the beginning? So it's a different type of IP, so it's not the usual stuff like we used to. The biggest thing that you should already see is we've got a matrix. So all of these are cities. So we said, I told you before, it's not always the case, but when you see the same topic for all the columns and the same topic for all the rows, then you can see it like a matrix. So it's just like item I, so city I, so all of them are cities, just city 1, 2, 3, 4. All of these are regions, 1, 2, 3, 4. So it's now seen as a matrix. So you can have city, you can then say city I and region J, then you know, oh, I'm going to need an Xij, which then tells me this is a matrix that I can use. So hint, hint, you can technically use Hungarian if you can set up a proper matrix. Right, but that's if you can set up a matrix of every information you need. Right, let's have a look. What do we need? All right, now first let's look at what it is about. So the company is called Overcharged. They receive credit card payments from 4 different regions. So credit card payments is what they receive. What regions do they get it from? West, Central, East, and South. Okay. Then they tell us that the average daily value of payments mailed by customers. So it's very physical. So it's like in the past we had to have checks mailed, and it's like a paper-based system where that should have been mailed somewhere and it then get processed somewhere. So it's still relevant to other kinds of scenarios where you're going to have something that you pay and it doesn't get cleared immediately. So it's the same principle. It doesn't get cleared immediately. As it waits, you are not getting that interest while waiting for it to get cleared because it's not in your account. So you can't get interest on it. Same principle. So the average daily payments that gets mailed from each region. They give us each region's payment and the average. And then they must decide where customers should mail their payments. So which regions should be the best options to mail it to. Then they tell us because Overcharged can earn 20% annual interest by investing these revenues. They like to receive payments as quickly as possible because the longer you wait for payments, the less interest you'll get. So for, in this case, every day that goes by, you're going to have interest that could have been built up, because they can earn up to 20% annually. Right, so maybe they earn 1% now, today, tomorrow 2%, and it's not in their account, so they're not actually earning it until it's in their account. So this annual interest is like an amount that they lose while waiting for it to be in their account, while waiting for the amounts to be processed. All right, so Overcharge is considering setting up operations to process these payments that we're now talking about. We call them lockboxes. They are going to be able to put them in 4 different cities. So you can either put a lockbox in Cape Town, Johannesburg, Durban, or Port Elizabeth. I know it's not the same anymore, but we're sorry, no updates yet. It's still PE in the slides. We'll go ahead. Right, so you've got 4 places where you can work with. Okay, so the idea is to either set up a lockbox or not. So you're either going to set up a lockbox in Cape Town, but now my question is, do you need a lockbox in Cape Town if the scenario solves it that it is not worth it to send payments to Cape Town, or checks, or cash, or whatever? Will it make sense to have a lockbox in Cape Town that you pay for if none of the payments will be sent to Cape Town? Thank you. No, 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 no. So it's very similar to the previous one. You're only going to have that lockbox if payments are going to be sent there. All right. It's pointless to have the lockbox and process payments there and have staff hired and what if, let's say, no payments will be sent there, because they're still deciding where to set this up. Okay, so hint, hint, we're still trying to figure out where. From where to where. Okay, so now in the table, they give us the average number of days. It's not actually the number of days, but the average number of days to be able to calculate the best route until the check clears. So it's the amount of time that that check takes to get sent and processed while interest is being lost, because they're not getting interest while it's being processed. Right, and then they can deposit, and then they can actually get interest. All right, so in the table, let's see what kind of averages in terms of days does it take. So let me ask you, from Region East to Durban, how many average number of days does it take for mailing and processing till it clears? What's the average from East till Durban? What's the average amount of days that it takes for it to actually clear? Perfect, 2, very good. From East to Durban. So I've got a matrix that I'm working with, so Xij. All right, so we need to know from where to where. So I would be our from and J would be our to. So you would then specify I would be region and J would be the city. Okay, but follow the same order as we do in assessment queue. If we don't specify, stick to row by column, like I taught you before. Stick to row by column. So my rows are the regions, so I will be the regions. So you'll then say I. So not like I did there. Stick to row by column. So I would be our rows, which is our regions. And then that's from, because that's where it comes from. Then J would be our columns, which will be our cities, where it's going to. So 2. Right. So it goes from a specific region to different cities. Now, we are not going to get, how can I say, checks from region West to every single city. We want to figure out what would be the best locations to have lockboxes. So we want to know, is there maybe a better solution to maybe have all regions sending to the same city? If they can't send it to the same city, can 2 of them maybe send to the same city, so that we can have less lockboxes, which is going to cost us less. But we have to also remember, what do we lose in terms of interest? If we lose too much, then we put a lockbox everywhere. So that's the idea. All right, so let's see, how do we go about this? The annual cost of running a lockbox in any city, so all of them will have the same amount. They could have had different amounts, it's just in this case the same amount. So running a lockbox in each would be 50,000. Okay. So we already have a fixed charge, if you can see it like that. We already have a fixed charge of 50,000 because you pay for that lockbox maybe annually, but that amount is going to stay the same until you get obviously a change in increase, then you change that value. But that would be our fixed cost. All right, so let's see. Formulate an IP that they can use to minimize the sum of cost due to loss of interest and lockbox operations. So we know we're going to use a min, and we're going to add all the costs together. Add all of the costs together. Assume that each region must send all of its money to a single city. Okay, so if we go back, each region, so look at the table, each region must send all of its stuff to a single city. So if I look at region 1, I'm not going to send region 1 stuff to all of the cities. I need to decide which city would be the best. So in our case, obviously, we're going to go with the payment that clears the fastest, depending on the rest of the information we have, but that's the idea. Then region 2, so we're going to say maybe, for example, oh no, these are taking too long, so we pick that one. For region 2, oh no, these are taking too long, so let's pick that one. Right, obviously the bigger the information table we have, the less likely it is you can just solve by looking at it, right? But we have to set up constraints for that, just to make it clear. So if we say, assume that each region must send all of its money to a single city, and we set up constraints, we have to make sure that we set up a constraint to make sure you don't allow more than that. Okay, now remember, Xij is from, we said from region I to city J. So the whole idea is going to be, are we going to send from region 1 to city 1? Yes or no? So it's going to be binary. Are we going to send from city 1 to from region 1 to city 2? Yes or no? So it's going to be binary. So all of these Xij values will be binary that we will work with. Okay, so it's almost like the Hungarian task assignment, very similar. So we're going to say, okay, that's our idea. Xij is binary from region to city. Okay, let's go on. If we then want to create constraints for that, where each region must send to a single city, you're going to set up constraints. So let me quickly ask you to see if you remember a bit from the task assignment. Create a constraint for region 3 to make sure that it only sends to a single city. Let's see if you guys remember. Create a constraint for region 3 specifically to send it to a single city. So one of these. Yes, equals 1, perfect. X3J, perfect. Nandipa, very well done there. So X3J is perfect because what are the variables for this specific row? We said from region to city. So it's from region 3 to city 1. From region 3 to city 2. From region 3 to city 3. From region 3 to city 4. And we only allow on the dot 1 because they can only send to a single city. And we do want them to send to a city because you only have 4 regions for 4 cities. So we have to force it. So very similar to task assignment. Very well done, Nandipa. So X3J equals 1, where you sum them starting with J equals 1, ending at 4, because there's 4 of them. Very well done. Okay, so that's the idea for your constraints based off of that. So you now know where those constraints come from. Okay, but the hard part is setting up that objective. Just a quick note, there is no limit on the amount of money that each lockbox can handle. So each lockbox, so just to make it clear, a lockbox is going to be in a city. So if we're looking at putting a lockbox in city 1, that would have been the constraint for the lockbox in city 1. That would have been the constraint for lockbox in city 2, and so forth. But they're saying there's no limitation, so there's no constraint needed for those columns. No limitation. Right. Now let's see how to set up the objective. So the objective is the hard part, and then the rest is very easy. Okay. But this specific lockbox, the other examples you'll see, it's the same principle, just the objective that's a bit easier to work with. Okay, so the objective, how do we set up those values? So those values, please don't get a shock, comes from this. Okay, don't get a shock, you'll survive. All right, so where this comes from. So you saw these variables, and where do they come from? I is the from and j is the to, right? Now each lockbox costs a certain amount, and you have a certain interest that can be lost and a certain amount of days that it's kept if you send from that region to that city. So they're very much the same, except you see from region west going to the different cities, it has the same amount for its actual cost. So just to go back here, so remember they each had their own payment mail cost there that we have here. So that's specifically for West. All of them have the same interest that they can lose. So this 20% applies to all of them. So the same interest that can be lost, and we want to minimize the interest that can be lost. And you should now by know in third year, know you can't work with a percentage. You have to times it by 1/100 or just divide by 100 to get 0.2. You can't work with a percentage. You have to make it a decimal. And then lastly, how much is lost per? So if I quickly look at region west only, from region west, it will be the amount that they could get times the interest on that amount times the amount of days it takes to clear, because that's how long it's going to take for them to be able to get that interest on that amount. So that's the amount that they're actually going to lose. Right, from region west to city 2, it's going to be the same stuff except for 6 days. To city 3, same stuff except for 8 days. City 4, same stuff except for 8. So you'll see there in the table the differences. So 2, 6, and 8, 8, but the rest stays exactly the same because you're trying to minimize the loss that you could have gotten. So remember the 0.2 is the annual interest they could have gained on this amount that they normally get if they go and get, how can I say, made it from west, from region west. And this is the amount of days, so region cost, if I can say it like that, interest, and the amount of days that it takes to clear. So that's the amount of money that they're going to lose while waiting for it to clear. So they're still waiting for it to clear. Remember, all of this is to do with those values that are, so I'll just recap again. So all of these values are while they're waiting to get that money. So overcharge is saying, if I send payments from region 1 to city 1, it's going to take 2 days for it to clear, meaning those 2 days are how long I wait before that money comes into the account of overcharge. So overcharge does not have that money, but if overcharge had the money, it would have been 2 days times the amount of interest that could have been gained on, so I can actually put brackets here, the amount of interest would be, remember everything's annually, so the amount of interest would have been on that 70,000, that's still an average that they're working with. So that could have been saying if they send it from west, that would have been the average interest that they could have gotten on the money. Okay, but how long are they waiting before they can get actually interest on that? 2 days. So it's 2 times the amount that they are that they could have gotten in terms of interest, but they're not getting because we're waiting. So average number of days that it takes for mailing and clearing. So it's not in their account. They're waiting for it. So they're losing that interest that they could have gotten if they had it in their account for those 2 days as well. Does that make a bit more sense? So all of this is basically saying they're waiting for the money. So if you have a savings account, you can't get interest if the money's not in the account, right? It's like saying, I've got 400 Rand in my pocket, I'm saving. I'm not going to get interest until it's actually in my account, right? So the longer I wait to go and deposit the money to get interest, the more I'm losing interest. The more I could have gotten money on interest, but I'm not getting it because it's not in the account. So that's what's happening here. So the longer it takes to be in their account, the more it's going to be. So it's times the amount that they could have gotten. So if we go back here, what's the average daily value that people normally mail from Region West? So they normally mail a value of 70,000 Rand. It's not the actual value. Remember, some person can mail a 2,000, someone can mail a 3,000, someone can mail a 50,000. At the end, the average is then divided by the number of people. So it's just an average value that we're working with. That average is then multiplied by the amount they can earn. We're not saying they're going to definitely earn 20%. They just can earn up to 20%. So we're going to say, what if they earn the maximum amount of 20% on that given day? Then we're going to say, okay, compare all of them with that 20%. What would be the worst? Right, if they had different percentages, then obviously that would be included in my calculation to say, okay, then they won't have all 0.2 necessarily. Right, but we take the maximum amount because we're comparing all of them to each other to see what would be then the least amount of loss in terms of interest. Right. Leonard, you're more than welcome to convert it. It's just not a must. So because all of them are literally using the same interest, it doesn't, well, even if they had different interests, but still yearly, it won't make a difference because you're just in actual fact trying to figure out where to send where, from where to where, which would give you the best. So whether you convert or not is going to give you the same answer. It would be more appropriate to convert, yes, of course, to go and say, okay, let's go change that per day. But I mean, how do you know how much per day will be actually invested? You don't know. So in that case, you would then have to go and do some proper research to figure out how much do they get interest per day, because that, yeah, it's not always a straightforward thing. No, Nandipa, no. Fixed amount is just a lockbox, purely just a lockbox. We'll get back to the lockbox very soon. All right, but no, nothing to do with the fixed charge. No. Right. But yes, you can go and change it to per day, but then it will affect all of them to be the same anyway, right? Because it's still overcharged. That's earning, or can earn, I'm not saying earning 20%, but can earn up to 20% annual interest when investing in these. So they're looking at the 20% for each of the regions and checking which would be the lesser of the four to minimize it. All right. Yes, you could use that value, but it's going to be very crazy to work with. But yeah, you can use it, Leonard, because it's going to be all of them. Literally, all of them are going to be multiplied by that. All of them. Literally, right? But the main idea is to say we're calculating the annual loss. So you can work in the daily loss. It's just rough. But we're working out the annual loss. They're not talking about Region West to Cape Town in this week, and then Region West to Cape Town in another week or another day. They're not, let me make it clear. So from here, it's an average. So it's not saying, they're not giving us values to say Region West to City 1, 2 days on day 1. when it gets sent on day one. It's literally just saying it's an average of this amount of days, no matter if it's in a year or not. They just give us averages. Technically, they should have said these are averages per year, but then it would have made a bit more sense why we used the 20. But yeah, they just give us averages to work with, and then we say, okay, if that's the average that we normally get, okay, then we can calculate the loss annually. So we then calculate the loss annually with that 70,000 because that's also an average. That's not an actual value, that's just an average that we're working with. All right. So that's the idea. That's the only hard part of this. I'm going to show you where it becomes easier. But the only hard part is then to create the objective function. We literally say, okay, how much is it specifically from West to Cape Town? So you do your annual loss in terms of interest, your average in terms of region West, the amount of days it normally takes on average to clear, right? If you wanted to work with the daily loss of interest, it will still work out the same. It's just not going to be that fun to calculate because you'll have a lot of fractional decimal values that will make it quite hard to work with. But yeah, it will still work. But for region West, all of this will stay exactly the same. It's only the amount of days that differ. From Central, if you look at them, those stay the same. It's just the days, averages that differ. This stays the same. It's just the days that differ because they gave us the 0.2 or the 20% for all of them, and the rest is different. All right. Okay, but there's nothing more to that. It's purely just saying, okay, this is how I get my objective values to actually calculate the annual loss. Right, so if you have these values, you remember you can divide by 1,000, and then when you get your answer, your Z answer, then just multiply by 1,000. So that's where the 28 and the 84 and the 112, all of those values come from. So it's just a objective function. That's hard. For the rest, it's as simple as saying we set up those constraints. So going back here, they said a region can only send to one single city, and then we said it's going to be equals to 1. So you have to set up constraints for each region to say equals to 1. So I'm just going to draw it out, blah, 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 equals 1, equals 1. Then they said the lockboxes, which is literally referring to the cities, are not limited. So no constraint needed there for these. And then we need to now think of the fixed cost. So now we get to the fixed cost, which is now specifically just for binary, because everything Xij is binary. So when we create our Ys, it will also be binary, and everything will be binary, which makes it actually easier to work with. But let's see. Okay. So lockboxes can be in different cities. So like I said, the lockboxes are specifically for the cities. So either a lockbox is going to be bought or not, or actually set up or not. Okay, there's always setup costs to set it up, or to rent a place, or to hire staff. So either that payment is going to be made or not. Okay. Now, what's the payment for a lockbox? Let me go there and then you tell me. What's the payment for a lockbox? Perfect, 50,000. Very good. So the payment is 50,000. So whether it's in Cape Town or Johannesburg, each of them are going to cost 50,000. And I told you, please be careful. Don't just go and say, okay, why one 50,000? Because all of them cost the same. No, there's still different lockboxes. You have to know, if you say why one, you have to know whether this is specifically going to have a lockbox or not. Okay, what do you mean? Whether the city is going to have a lockbox or not. So if we make this for Cape Town and it becomes a 1 there, then it means it will pay 50,000 due to the fact that Cape Town will have a lockbox. If it's Y2, we're going to have the same amount, yes, sure, but is specifically for Johannesburg. So if there's a 1 there, it's going to refer specifically to Johannesburg. If we look at Y3, yes, it's the same. Yes, yes, yes. But the Y3, if I make that a 0, we're not going to have a lockbox in PE. But it tells me exactly where will I have a lockbox and where will I not. And then if I have a lockbox there, it's going to be a 1 for that Y. If I don't, it's going to be a 0. So the same principle. It's just the fact that when we get to the linking constraints, it will be a tiny bit different. Okay, so what I want you to see right now, the Y's are the same. Quickly, why am I adding? Why am I not saying minus 50,000, minus 50,000, minus 50,000? Quickly. I like it when the thing says many people are typing, then I'm like, yes. Yes, we're minimizing the costs. Very well done. So you're adding all the costs together. Well done. Very good. Okay, so when we get to the objective, you literally have to then go and subtract those because you're minimizing the costs. So in the slides I just showed step by step that the Y's will be zeros for now because you have to still remember to add those linking constraints. I just want to see on the slides that they included the, yeah. So there's your 50, 50, 50, 50. I'm not saying 50,000 because I divided everything by 1,000. So even this needed to be divided by 1,000. Please be careful for that. And then Deepa, so they would have gained interest if that money was in their account. So we're basically minimizing the interest lost. So the money they would have gained but are losing due to it not being cleared and going into their account, that's what we're trying to minimize. So it's definitely lost, the amount they're losing. Right, so as they're waiting for the money to be cleared to their account, that's the amount they could have gotten if it was in their account already. I hope that makes sense. But yes, minimizing costs, and your lockbox has a cost, as well as your amounts there that's specifically for losing interest. Awesome, cool. So specifically for losing interest. So in the start of the scenario, it sounded quite like you were going to maximize the amount of interest. But then when you get to that table, it's the amount of days that it takes before they can actually get that money, before they can have it in their account and start earning interest. So while they wait, they're losing. So the sooner it gets to their account and they can start earning that interest, great. But then, yeah, they're still waiting. So you want to minimize the time, basically the time they wait, but in terms of costs. So it was basically, that table was basically to convert all these days into costs. So going back here, all these days to convert it into costs. So if I were to convert this into a cost, so 2 days is how much it takes. And for each day, so per, so we times per, for each day, it could have been an interest of 0.2. And what do they normally get in terms of money? So what that interest would have been on? Because you can't just say 0.2 times 2. Like that's just saying interest per day. But what's the money? Like how much are they actually getting interest on? So if you save 200 Rand in your savings account, it might not be the same as 300 depending on what type of interest rate you choose. Right, so it's not going to be the same. So if it's 20% is not the same on 200 and on 300. So it will be a different amount as it increases. So we times it with the amount. And the amount for West was on average 70,000. So it's converting it in terms of cost to say, let's minimize the amount of loss. And then when we have the loss amount, we can then subtract that lockbox cost. Right, otherwise you couldn't have minimized the objective function, because how would 2 days relate to a cost of 50,000? You can't subtract 50,000 from 2 days. that does not correlate. There's no way of working with that. So you had to put this in terms of some kind of cost or profit. If you wanted to work in terms of profit, then you would have to, I don't know, you don't have the opposite amount. Maybe you can add all the days together and then say, instead of 2, you do the opposite. So that amount minus 2, and then you times it with everything. You could have done that. That's quite a very weird approach. That's a bit more kind of a statistic approach where you have like the probability of this, then 1 minus this is the opposite. So I would avoid doing that though, because you don't know it's all averages. You don't know exactly how many days in terms of total. Like you don't know the total amount of days. There's just averages that you're working with. So you work with what is given. All right, but going back here, how do I set up those constraints? So when you start, you'll see the y stays 0 because you need some kind of linking constraints. I hope you see how much simpler it is if everything's just binary. It's just binary. So how these constraints work, what's the max value? So this is m. So it's still that x, but now it's xij though, but x something less than or equals to m and the y that fits to that. So I don't know if it was y was the city, so it should be j because j was city. Right, so if I go and do that, I go specify exactly which variables is for that specific city because I have to link the lockbox to those specific variables. So going back here, for city 1, which variables? For city 1, which variables? Because it's not only one variable. We did city 1. Which variables? You guys tell me. City 1, which variables are we working with? For city 1 specifically. Perfect. So you're working with x11, 21, 31, and 41 because it goes from I, which is region, to J, which is city. So it's going to be region 1, city 1, region 2, city 1, region 3, city 1, region 4, city 1. So those are the values, x11 plus x21 plus x31 plus x41. So those are our xij values. Less than or equals to some kind of max value and then the y that links to it. So which lockbox? So I said y1 is a lockbox in city 1. So y1. Okay. Now the max value. Guys, it's binary. If it's max, they're all going to be 1. Because they can only be either 0 or 1. The minimum, they'll all be zeros. The maximum, they'll all be 1s. So what's the max value they can possibly be? If all of them are 1. Yes, 1. And if all of them are 1, what's the max value? Perfect. So if we literally put, how can I say, all of the regions to send to city 1, all of them will then be a 1. Yes. And then that will give us a max value of 4. So if your x variables, so make a note, our xij is binary. So if our x variables are binary, your m value is just adding up the 1s. So how many? So the number of variables that account for that specific check. Right, or that specific y. In this case, our specific lockbox. Right, so it's as simple as that. When it's binary, you smile because you're literally just counting up how many. There's no getting a max value. You count up how many, and then you say, okay, that's going to be our max value. It's still the same constraint form. And then bring it over to the left, it becomes a minus. So this is lockbox for city 1. You can say Cape Town, but then this is lockbox for city 2, lockbox for city 3, and lockbox for city 4 to make sure that if they get any payments sent to there, then it's going to become a 1. Right. But yes, Anika, so if the xij's were integers, then you have to compare them with your other constraints, like we did previously, get the max value and then use that. But in this case, because xij is binary, we simply just say how many can possibly be there, and we count them up, and that would be our max. Because you're just saying how many binaries, so how many ones can there be to get max. So all of them would be ones, and then you count them up. But let's test it. I mean, it's always good to test it. It's very nice to just see it working in action. So just to go back here. So you saw now what I mean there. Let me just erase this to have some space. Why am I not including the coefficients? Because it's just whether we're going to put a lockbox there or not. The objective function is taking care of our coefficients. Right. So here we're going to say, okay, will this work? Will this make sure that that Y1 with the 50,000 becomes a 1 if we need it? So we're not going to focus specifically on Cape Town. So if it becomes 1, we have to pay the amount. If it's a 0, we're not paying the amount. But when are we paying? We're only paying if one of the regions actually send the money to that city lockbox. Because if they don't send it to that lockbox, why have it in the first place? So if all of these are zeros, will that be true? Okay, then yeah, we can ask you to do branch amount simplex, or like this one, the previous one we couldn't, but this one can do Hungarian if you set up that. But without the, yeah, you can't include the lockboxes, so I highly doubt Hungarian. Branch amount simplex, cutting plane, you can do that if we keep it small. It's very possible. But the main focus is the setting up of IPs, yes, today, yes. You have to be able to go and solve on your own. So when you go to branch amount simplex, remember I told you to add some constraints for binary to make sure it's already less than or equal to 0 for each variable. And then for integers, well, you solve it with as is, you get fractional values with either dual or primal. Then once you get your answers, then you start doing branch amount simplex. So the value doesn't matter if it's a y or an x, you start with the one that's closest to 0.5. Yes, you now have different variables, yeah, which makes it harder to check, I know. But they still do the whole which one is closest to 0.5. Take the smaller subscript. If you want to, you can always sort out the one and then the other. So you can focus on getting integers first and then binary. Or first binary and then integer, but yeah, you have to decide what are you focusing on getting. In this case, if I look at xij, everything's binary, so here it will literally just be try to get all of them as binary numbers. So 0 or 1, 0 or 1, less than or equal to 0, another one greater than 1, less than or equal to 0, greater than 1, constantly until you get all just binary numbers. All right. But something like this would be quite large, so I cannot promise that we won't ask you to solve. I'm just saying it's unlikely, right? It's unlikely to solve something that would go so big when you do branch amount simplex, but you should be able to if we ask you to, right? For which constraint, Anika? Oh, for this, I just purely based off of that small thing that we said, the formulation. You'll see, I'll show you now why it works, but that whole thing where we said less than or equal to my. So that's just where it comes from, but I'll show you how it works just to make it clear. Okay, so let's see how it works though. All right, so if I put a bunch of zeros, that means that region west is not sending. Region central is not sending. Region east is not sending to Cape Town. Region 4 south is not sending to Cape Town. So if none of them are sending to Cape Town, Do we need a lockbox? Let me ask you guys. Do we need a lockbox? No, 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 no. So if y1 stays 0, let's see if it would be okay. If I put all of this in, 0 plus 0 plus 0 plus 0 less than or equals to 4 times 0, is that true or false? True. So the y1 equals 0 is perfectly fine. Should it be 0? Yes, we don't want to pay for the lockbox. So 50,000 times 0 is going to be a cost of 0, which is perfect. We don't want to pay for the lockbox. Right. Now, it's not going to change the y1 to a 1. It's going to leave the y1 as a 0 because you want to minimize costs. So it's not going to want to add those costs together if it doesn't have to. So it will only change the y1 to a 1 if it must. All right, so if you go and make the y1 a 1, you'll be like, yeah, but it works. No, that's not the point. The point is it tries to minimize costs. In order for us to minimize costs in terms of the lockboxes, you'd rather have those as zeros in the y's to not have additional costs. So it will only change that y1 to a 1 if it's a must. Okay, but let's see when is it a must. Okay, so let's try one more. So let's say I'm only going to pick some of them, not all of them, because you'll see the idea. So let's say this one is a yes, and this one is a yes, this one is a no, and this one is a no. If we substitute it here, it's going to be 1, 1, 0, 0, less than or equals to 4 times 0. Okay, so 1 plus 1 plus 0 plus 0 is 2. Is 2 less than or equals to 4 times 0? True or false? False. Very good. False. So what's going to happen is it's going to say, no, 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 no. That y1 that's a 0 cannot be a 0. So we try to make it a 1. Will it now work? Yes, very well done. True now. So it's going to go and say, no, that y1 needs to be a 1. Which means I'm going to pay for the lockbox. That's perfect. I should be paying for the lockbox because I'm sending stuff to that lockbox. Right, but what's the max amount I can send? So how many places can I send it to or from? Sorry, said it wrong now. How many places can I send it from? How many regions? In total, I can send from 1, 2, 3, 4, if all of them are 1s. So if all of them are 1s, that's the maximum amount that can be sent from because there's only 4 regions. So if I add that all up, let's start with y being a 0 first. 1 plus 1 plus 1 plus 1 is 4. Okay, 4 less than or equals to 0, that's going to be false. So it says, no, no, that won't work. So 4 times 1, we make the y a 1. Then it's going to be 4 less than or equals to 4. Do you see the limit is 4 because our max is 4? There's only 4 places it can come from, maximum. Now it becomes a true, and it says, yeah, that needs a 1 inside of y1. Why? Because I need to pay for the lockbox. Now my question is, can I go more than 4? Or should I allow more than 4? Should my max value be more than 4? I think it's logical to say no, but why not? You only have 4 regions it can come from, so it should not go more than that. So less than or equals to would work to include all of them in terms of the 1s and the 0 for the other one, but you can't go more than that. It'll also not work because then you're going to allow this false to have been true, and then it would never have changed the y to a 1 instead of 0. Okay, so less than or equals to is a must. Greater than will not work. because it wouldn't have changed a y to a 1, so it had to be less than or equals to. But you can't say equals to because you should have allowed a 2, a 1, a 4, a 3, anything as long as it doesn't go over the maximum amount of regions that could send it to that lockbox city. And that's it. That's literally it. It's only that part. The logical constraints are going to be very much like the capital budgeting, where you have to think, okay, if it's in that lockbox is placed in that city, should we place more? Meaning, can we place more? Let's give you an example quickly. So let's go to the table. Oh, let's do it here. Now, look for the table. There. So my question is, if I give you a constraint to set up to say, either they have to have a lockbox in city 2 or in city 3, how would we set that up? We need a lockbox either in city 2 or city 3. I don't care where it comes from. I just want to make sure that we limit it to either city 2 lockbox or city 3 lockbox. Am I going to use xij or the y variables? Yes, Caitlin, I'm going to use the y variables because I'm limiting the lockbox, not where it comes from and where I'm sending to. I'm limiting where I can have lockboxes. So then I'm going to look at y, because y is specifically the variable for whether or not I'm going to have a lockbox or not. So you'll then do that whole, okay, y2, y3, what do I put in between to make sure it's going to be either or? You play around because it's purely binary, 0, 1, 1, 0, 0, 1, 1, 0, oh, other way around, 1, 0. So purely binary constraints like we had before. What if I ask you to make sure that region 2 can send to less than or equals to 2 cities? Region 2 less than or equals to, so region 2 less than or equals to 2 cities. Which variable will I use? Yes, then I'll use xij because now I'm specifically looking at the from and the to. So if I want to limit that, I have to go and specify the variable specifically for from and to. So xij is where we specify from and to. All right, so that's the idea for those, because it's still binary. You're still going to go and say, okay, I'm going to then go and say x. Region 2 is going to be 2, 1, 2, 2, 2, 3, and 2, 4, and I make it less than or equal to 2 because they're purely binary. So if I play around with this, if I make 2 of them 1s and the other 0, is it allowed? Yes, it's allowed. Should it be? Yes, it should be. If I make 3 of them 1s, should it be allowed? No, I said less than or equal to 2. Is it allowed? No, it's going to give me a false. So it's the same as we used to do before, just more. All right. Okay, let's see. What else is there to do this? Okay, so the if then for this is very much the same, like very much the same. The only difference is you don't have one variable. I mean, you now have to include every single thing for that specific upper or lower. And the max is now not a maximum amount in terms of integers. Here you're counting literally how many are there. Right, so I'll explain these constraints now, but you're literally counting the max value because they're all binary. But let's have a look. How does it work? What is this for? Okay. So if customers in region 1 sends their payments to city 1, so now we're saying if x11 is greater than or equals, well, not equals, I'm saying greater than 0. I'm not saying equals. Why am I saying that? Because we're saying if they send. They can't be sending if it's equals to 0. Then they're not sending from region 1 to city 1. Okay, so it must be greater than 0, which we'll discuss now. If customers send, then no other customers may send their payments. So meaning this is the one either. So it's either this or now your other one is going to be, what's the or? No other customers. So meaning no other regions. Remember the customers were specifically sending from regions. No other regions may send to 1. So meaning region 2 cannot send to city 1. Region 3 cannot send to city 1. And region 4 cannot send to city 1. None other. What's the max value? Here it's 1, 2, 3. It's max value of 3. Okay, so it works very similar to that previous one where we had the upper and the lower and the, what do you call it? Yeah, it was upper and lower. Where we had all of that. Very similar, not exactly the same sadly, but very similar. So here you would then go and say minus 3 with some kind of dummy less than 0. So just to take you back to see the stuff from the other one. Let me just quickly open that one. And I already closed it, so now I just have to go open it again. Where's fixed charge? So just to show you the formula again there. If you feel like you're struggling to set it up on your own. So still the positive x minus upper times 2 with a dummy, less than or lower, minus x, but now you have few x's for the second one, plus upper times 2, dummy, and less than or upper. So you still have those constraints. I'll just quickly discuss it again. Let me see if I can open it here. Okay, let's see. So it's very small. Let's see how I can write it out for you. Did we do it step by step there? Yes, at least. Can't just see that I'm not wasting time. So, okay, so if x11 greater than 0, so if we focus on that one, just right clicking there. You'll have your x variable, then this one is a bit tricky because of this. It would have been a minus, but because of that greater than not being an equals, it's not positive. But just one thing though, guys, usually we would have said upper times 2, but here you do not do so because it is binary. Here your upper is simply your upper, so you count them for this one, 1, 2, 3. That's the max value, so it stays the upper. So here the upper stays 3, upper, upper, upper. That's lower. Lower we said is that 0, lower, so upper, upper. So just to make it clear. Let me just rewrite those. So it's x minus, so upper would have been times 2 if it was integer, some kind of dummy, less than lower. Then you had a minus x plus upper times 2, which in this case will not times 2 because it's binary, and this makes it upper. So just to make it clear where we get them from and just to show you the small difference. Right, let's see. Okay, so the one we're going to have is which x variable. So we're going to now figure that out very soon. And so I'll talk about which variables just now. But let me start with the other ones first. So we'll talk about which variable now. So we're going to have a minus there with the upper. Upper is not going to be times 2. Yes, it's basically the binary version of big fixed charge, yes. Whereas now you see the max value is not going to be the upper limit times 2. It's just going to say how many can they max be. So the upper would have been 1, 2, 3, where the lower would have been 1. But that 1, we don't use 1 due to the fact that it's going to be literally 0. So your lower would be none of them for this. Okay, I highlighted too much. Wait. Let me just make it clear. For this. So your lower would have been none of them, so 0, and your upper would have been all of them, which is 3. Just makes it confusing with this either part. All right, so all of them would have been an upper of 3, none of them would have been a lower of 0. So you would have had, now instead of this, you would say, no, that's not going to be it. And your upper is going to be a 3, and your lower is going to be a 0. All right. So then when you substitute in, you'll have then your 3 with some kind of dummy, but whatever dummy you use, you could keep on using the same dummy for that specific either or if then in this case, if customers do this, then this. So it's very similar, but it's not exactly the same as either or. The if then is just that has a slight difference. I'm going to show you exactly now where the difference comes in. But you're going to have then minus 3 less than or equals to the lower, which is 0. And then the other one is then the difference. I'm going to make it in red. Let me make it in red there, is this. So that will then be a plus. This is specifically for if then. So it's not either or because we're allowing none of them as well. So it's not specifically either or. It's close to either or, but not exactly the same. Because either or, it's either the one or the other. But now we're saying, oh, well, it doesn't have to be to all of them, right? We don't have to send to city 1. Please take note of that. They never said we have to send to city 1. Never. So now we should allow a 0 and a 0 as well. So the lower is literally 0. We're allowing that to be possible. Right, and that becomes a plus. So there's a small difference there. So now we go and say, okay, how do I set up the next one? So sum xij, but positive now. It's not like exactly like the previous one. And then we're going to have a plus. What's our upper? It's 3. Same dummy. So whatever you call this dummy, same one, still the same constraint that we're dealing with. Less than or equals to upper, which is 3. So that's the difference for the if-then constraint. Now, which variables are we working with? So just to make it clear. So this one is specifically for the greater than. I know it's going to look very weird for the greater than side. I'll explain now. And this one is going to be specifically for the, well, you can say less than, but in this case, it's, did I swap them around? Yes, I swapped them around. Apologies. That's why it didn't make sense in my head now. Okay, so this one's going to be minus 3 is going to be for the less than side. Apologies. And this one is going to be for the greater than or greater than equals. Doesn't matter. Greater than or greater than, just as long as it's greater than side. So just to show you there, let me use a different color. This one applies to that, where we're saying we don't want any of them to be something. So it should be less than or equals to 0 or equals 0. And that one should be greater than 0. Right, sadly, it's just a way of helping you. I'm not saying that you need to actually parrot this. You should actually be trying to set this up on your own. Right, but as soon as you have an if-then constraint or an either-or constraint, you have to play around with more than one constraint. With some kind of dummy, playing around with switching it on and off. Right, so if-then, either-or, multiple variables, meaning you don't just have x1 and x2 and then you're comparing them between each other. You have literally a case of either this could happen, then or this. If this happened, then do this. So it's kind of like there's two sides of the scenario. There's two sides that you need to check. If that happens, you're going to have two constraints of some kind of dummy switching it on and off. I just try to give you formulas because not everyone is that good at setting up these kinds of constraints. So you can use it as formulas, but I'm not saying it will be the best path to follow. You should technically try and set them up on your own to make sure that it works. But it is hard to set up. So I'm trying to give you kind of like things that you can use if you get stuck. Right. But that logical constraints Excel sheet is also something we set up to help a bit there. But there's specifically, if this, then this. Either this or this. So you have two things that you are checking, and it's going to be one or the other, or you're going to have two sides that you have to check. Right, that's why we have all of this. If it was purely just, how can I say, either they send to 1 or 2, then it's not if this or this. It's just either they do this or this. Then there's no if statement. Then it will be much easier to set up like we did before, like last week. That's been a while, but it's not that long ago, I'm hoping. I just wanted to go to this line. So it's very similar to this, to the integers, not exactly the same. Just give me a second. I want to just swap. Why is it not doing this? Yeah, it's not showing me the right slides. But anyway, so I want to show you here, just to make it clear, where's that one? Where did I show you the first? Here. So here it doesn't matter which one is which. I mean, your lower is your lower. I mean, less than or equal to 0, that's your lower. Your upper is greater than or equal to 20, that's your upper. You just create the constraints based off a formula. So it's either or. Right, either or will work the same with binary, except you'll have more than one variable that you're working with. Sadly, this is an if-then constraint, so it's a bit different. It's not just either this or this. You can have zeros for everything as well, which makes it a bit different. So then you'll be playing around with this one. Right, but you can try and play around with changing the variables to different places and see how that would work out. But let's see how it works out with this. All right, just to see that it works, and then you know what to try and do to get yours to work as well. Right, otherwise you won't know how to test it. So then it's quite pointless to know how to set up your own constraints. So we're going to be using these constraints now. Let's see. So we're going to have x21 plus x31 plus x41 less than or equal to 0. The other one is going to be x11 plus 3, oh, I forgot my dummy, minus 3 dummy. And this is plus 3 dummy. Same dummy, less than or equal to 3. So if you see patterns, you can study it, or you can try and actually create these on your own. All right, so let's see, how do we work with this? So they say if x11, then not x21 or x31 or x41. So that's what they're saying. Okay, that's what we want. So now we play around. We say, okay, so if we substitute a 1 here into x11, now be careful. If we substitute a 1 there, should there be any 1 in x21, 31, or 41? If there's a 1 in x11, should there be a 1 in any of the other 3? You tell me. No. So let's make sure no. Right. No. If x11, then not anything else. Okay, so that should be true. Okay. Now remember, we're playing around with the dummy first being a 0, and then later on it becomes a 1 if necessary, but if nothing gets a true, then no. Okay, so it must be a true and a true before it will be allowed. Okay, it must be both true, then it will be allowed. So if we play around with the dummy and we say, okay, all of them zeros with a 0 in the dummy, then the 0 will be a dummy here. The dummy will have a 0 here as well. Okay, dummy must be the same. x11 and x21 is not the same variable, so there I put a 1. Okay, let's see. 0 minus 0 less than or equal to 0 is true. 1 plus nothing less than or equal to 3, true. So it allows all of this that I stated here to work. because true and true is fine. If you want to take a picture, you can. I'm going to erase in like a few seconds. I'm just going to move my mouse. Okay, I hope you got your screen grab. Now I say, okay, no, let's try something else. Let's see if something else would be a problem. Okay, so let's leave the dummy first. Let's do that. Okay, so now we say, what if I make one of them a 1? Or 2? Or all 3? So either or, they're going to add together. Okay, so let's say 1 plus 1 plus 1. So that's going to be a 3. Okay, so 3 minus nothing is 3 less than or equal to 0. That's false. So it won't even go to the next one, even if the next one is true. We know that 1 plus nothing is going to be less than or equal to 3 true. But they're not both true, so this will not be allowed. So now it goes and says, okay, maybe let's try to make the dummy a 1. So the same stuff, but the dummy a 1. Okay, same stuff, but the dummy a 1. 3 minus 3, 0. True. 1 plus 3 does not work, and it should not work. We said if x1, 1, so let me just highlight, if x1, 1 is a 1, nothing else can be a 1. So this, where we've got 1s here, should not be possible, and they're not possible because it's not allowing it. What if I make it less? There's a chance for your screen grab. What if I make only one of them? Let's see. So you have to be testing this to get constraints that would work. So let's make that like that. Okay, let's see now. So 1 plus 0 plus 0 is just 1 there. I just skipped the writing out of it. 1 there. Okay, so 1 minus 3 times 0 is 1 minus 0. So it's 1 less than or equal to 0, so false. So immediately it would change dummy, but we check. 1 plus 0 is 1, less than 3, that's true. But it won't work because they're not both true. Now it changes your dummy to a 1. Okay, 1 minus 3 is minus 2, less than or equal to 0, that's true. 1 plus 3 is 4, less than or equal to 3. That's false. It's not true for both, so those values will not work. You already saw that if we made it a 0 for all of them, that worked. But now my question to you. Time for a screen grab before I erase. If x1, 1 is 0, does it matter what we do with the rest? If x1, 1 is 0, meaning we don't send from region 1 to city 1, does it matter what we do with the rest? Think of your binary constraints we had last week. If x1, 1 is 0, does it matter what we do with the rest? Thank you, Kenneth. No. If you make that 0, it doesn't matter. They only say if x1, 1 is then sent, then don't send from the others. But they never said what happens if not, so you don't restrict that. All of those should be allowed. So if I go and put a 0 there, let's see. 1 plus 0 plus 0, then that's going to be 1. Minus our 3 times our dummy, less than or equal to 0. The other one is going to be now a 0 because we're changing that specific scenario. Dummy must be the same, less than or equal to 3. Now we check. 1 minus nothing is 1, less than or equal to 1. Immediately, that's going to be a bit of a problem. Doesn't mean it's a problem for all of them. Just saying 1 minus 0, that doesn't work. Okay, 0 plus 0, that one is true, but we said no. Now it changes your dummy to a 1. So for both of them, it becomes a 1. Okay, so the rest I'm just filling in. Right, less than or equal to 0, less than or equal to 3. Okay, 1 minus 3 becomes minus 2, less than 0, so that's true. 0 plus 3 is 3, less than or equal to 3, that's true. Works for them both, so that would perfectly be fine for zeros as well. Okay, but you would then be testing, okay, what if I make another 1, 1? What if I make all 3, 1? What now? Right, so that's just going to change then this to a 3 and a 3. Right, 3 minus nothing is 3. That doesn't work still. 3 minus 3 is 0. That still works. Just can't go past the maximum amount because we said the max is 3 for those. Ugh, man. Right. So these are the most difficult constraints that you'll get. Literally, the most difficult constraints. But yeah, then that's it. Your if then is the most difficult. Either or most difficult when you have integers. But yeah, that's the most difficult we get with constraint-wise. Logical. Tomorrow we do set covering, but you'll see it's not that difficult. It's just the setting up. And then we get back to things that are more algorithms than constraints. If you like constraints more, then yeah, sorry. Now we go to algorithms very soon. But if you like algorithms more, then yay for you. But guys, you need some time to practice the exercises. Please do. The more you do, the better. The more you sit with someone else, also the better. If you can find some people to form a study group with and then just go through some of these and explain. Sometimes someone else says something that just makes you click. Or maybe you say something to someone else and you're like, oh, that's what this is, right? So please, if you can find some people to make some groups with, to have some study groups before you write a test, please do. I mean, that's how you learn. I know you guys are online, so it's probably very hard to do. Make a plan, like just make a post somewhere saying who wants to join me in a group or something. Join your programming group, your project group. Tell them, come on, let's make a study group. Let's go. Do something, right? Unfortunately, I can't but help you there, but yeah, I already went through it. Really? Is it easier online? I would have thought it's more difficult because you guys don't talk. I really thought you guys don't really communicate with each other. Less petrol usage. Yeah, hey, for everything has its own pros and cons. And some people are working and some people are sick and some people have family responsibilities. So yeah, I know. But on PC, I mean, or your phone. Not one of us is live, so we are always active on the PC. Thank you, Andre. That was funny. Now I know why you type so fast. So true. You don't get tired of seeing each other. So true. That's so funny. Yeah, that's where you guys are bored. Yeah, for the BI people, this is probably very frustrating. You're missing each other and you're like, no, I don't like to be just active on the PC. I want to see people. But for the same people, you're like, nah, I'm good. This is for me. Okay, but let me stop just making jokes, but I'm enjoying it. But yeah, I'll read your chats. Bye, guys. Good luck with the exercises. I'll see you tomorrow. This was already a lot, so tomorrow we'll continue set covering and knapsack. Enjoy your day. Good luck.